we're cached. Sweet. Is Christoph muted? Yep. Here, we got to go back here. Okay, so we'll go right there. Yeah, okay.
Joel, do you have a phone? Should you read comments?
Peter's going to hand me his phone. Hey, everybody. We are live here at Formnext 2024 in Frankfurt, Germany. Wie geht's? Welcome to the show. We got a lot of stuff coming up. It's going to be incredible. You're going to learn about a lot of really cool stuff, and we're going to get to talk to a lot of really cool people. And, oh, look at that. And we got some comments here. Oh, look at that. Hi. There we go. Hello. Oh, hey, can everybody hear me, and can you see me? I assume you can see me, but let's see. Let me know if my sound is okay. Let me know if the sound's okay. We're live. Yes, yes. Will Webbles, hi. PDX Serial Killer, it's 6 a.m., sir. Yes, it is. It is 6 a.m. back in my home time zone, the Pacific time zone, the best time zone.
Hey, never let the machines win is on.
Oh, really?
Yeah.
There we go. Everybody like that smash button? Yes, I want to 3D print, know where to start or where to buy. Oh my gosh, Michael. There we go. We've got, I think sound is good.
Unnecessary inventions in the chat.
Hey, look at that. What's up, Maddie? Good to see you. Sound okay? Okay, sound is good. Peter, here's the phone. We got a lot to get through, so I'm going to welcome my first guest to the show. Christoph, come on up. Hold on, we're doing the mics. We're doing the mics. Okay, everybody hold tight. Just kind of hang out for a sec.
Good, thank you.
Just a little bit. Okay, come on up, Christoph.
Hi, Joe.
There we go. Hey,
Hello.
Christoph.
Thanks for inviting me.
Thanks for inviting us
You're
to
most welcome.
Formnext.
You're most welcome.
This is Christoph, and he is with Masago, and Masago is the company that puts on this wonderful show.
Indeed, indeed.
How long has Formnext been a show?
It has been a show since 2015. So I joined the team, the launch team, if you will, in 2015. And it's now the 9th edition. And next year is our anniversary year, the 10th edition of Formnext.
Hey, can we come?
You're most welcome to, of
Yes,
course.
that's great.
I count on it.
You know, Formnext, a lot of people describe it as the largest additive manufacturing show in the world. Is that true?
I believe so, yes. Well, we have 860 odd exhibitors, so it's 4 halls packed with exhibitors, with technology, service providers, materials, etc., etc. So everything you need for additive manufacturing, of course. So yes, It's a big show.
It's a huge show. And I don't think people realize that if you haven't been to Formnext, you don't really get a sense of the scale of this show. Because when we talk about there's 4 halls, this isn't like your local gymnasium at the high school. This isn't like a college lecture hall. These are massive halls.
They're big halls.
Massive.
Do you have your counting app on for your run
for my
while you're
steps.
walking?
I got
my steps.
my steps. Hey, you want to see? Let's see.
Where are you at?
We're going to see how many steps I've taken today. Okay, here we go. We're going to find it.
I'll go first.
What's yours at?
7,000.
Oh, I'm at 4,200.
Okay, a little bit to catch up.
A little bit. I've been here a bit, setting up the stream, with Dave and with Peter. So talk to me about how you think Formnext has really helped illustrate the landscape of what additive manufacturing is.
Well, we started off in 2015
Right.
with 200 exhibitors, and it was really the core of additive manufacturing. So machine manufacturers, really, all the big names, we all gathered them here in Frankfurt.
Well, and just to be clear too, we're talking about the industrial side.
Industrial,
right?
exactly.
That's right.
That was always the focus, and still is the focus of Formnext, the industrial side of additive manufacturing. So really for industrial production, from 18 target audiences, from automotive, medtech, dental, all the way through whatever industry you can imagine, really.
Okay.
So that's where we started, and then we tried to build on that and include all the processes surrounding the core of AM production. So software, materials, post-processing, quality assurance, all that stuff that's necessary in order to make it industrial, to have the full solution and not just a machine.
Oh, I see. If you needed an additive ecosystem,
Indeed.
you now had all of the components to build it.
Yes, exactly.
Okay.
It's still tough to navigate, but
Yeah.
there are attempts to make it clearer for the future, of course.
Yeah. But there's been a change because the industrial focus of Formnext, while still here, we've seen a lot of consumer companies come in with big booths and big demonstrations, just like Creality is right in front of us. We
Exactly.
have Bamboo Lab here. Polymaker does a lot of consumer filaments. Prusa is
Prusa
right
is just
back
over
here.
there, yeah.
Yeah, but then right next to Prusa is like Mimaki, you know, an industrial provider. And so here's a question for you, and this is going to be really relevant for the audience. How do you believe the consumer additive market plays into the industrial landscape?
At the end of the day, it's people. So there are people behind the screens right now. There are people here who also have a private life and who have maybe a passion for additive manufacturing. And they may not be able to buy the big Nikon SLM machine, but they may be able to afford something.
Or should they?
Yeah, no, well, maybe not. And they may be able to fit a desktop printer in their garage or in their cellar, and start off with that. Getting the hang of it, and then for professional life, if they go into production, industrial production, then they have some sense of knowledge, or they have some knowledge to apply. And that's really important for us. And that's actually where you come in as well, I believe, because you make it accessible. You make additive manufacturing accessible to a wider audience, and not just the people who are already in the industry, but a broader audience as well.
Oh, I see. Well, what we like to do is talk about how the skills of the consumer 3D printing person, many of those directly translate to all of these industrial and rather professional companies. There's a lot of that know-how that can actually accelerate their growth within the larger additive manufacturing industry. And I think that's key, and I think that's what's really exciting about what we do here at 3D Printing Nerd, is being able to kind of tell the complete story.
Indeed.
One story here, can I tell you something really cool?
Please do.
So at Formnext, I believe it was 2018, I was visiting the GE additive booth. And no, was it 2018? Well,
Could be.
I believe one of the people there didn't know about consumer 3D printing. And so I was able to talk to them and get them interested in it, and by the end of the day, they had decided to go buy a Creality machine.
Fantastic.
And so here they worked with these metal additive machines,
yeah.
And now they have a Creality machine, and then we became connected on LinkedIn.
That's the Joel touch.
I guess so.
It must be. But that's also the reason, I guess, why you're nominated for the Ambassador Award.
That's true.
Yeah, I mean,
the AM Ambassador.
Indeed, AM Ambassador.
I do like, so Formnext has some awards, and 3D Printing Nerd, along with two other very talented people, is nominated for the Ambassador Award, AM being in capital letters.
Yeah.
So actually,
and you still need, I don't know if you need them, but you still have the opportunity to mobilize some votes for your nomination.
Everybody please go vote. I'd love it if you voted for 3D Printing Nerd, but go out and vote. I've posted it on the various social networks out there. But could you describe a little bit what the Formnext Awards are and why you think they're important?
Yeah, sure. We had a startup challenge already in the past, so we tried to promote young, talented companies who really bring value to the industry, bring new ideas, new technologies. And then there was also a design challenge alongside that, but it wasn't one complete concept. So we decided, let's do something comprehensive, and we added, alongside to the startup category, we also added a rookie category. So anyone who hasn't founded a company yet, they can also apply for the Rookie Award for next year now. But anyway,
okay.
So anyone who's before founding their own company, join in. There's the design category, of course, is still part of it. Sustainability. I need to have a quick look at the banner.
Take a look at the banner's off to our right here.
Sustainability, Ambassador, of course, and Revolution, so a new technology that really makes a difference for the additive manufacturing realm. So 6 categories, there are 3 finalists per category, and you can still vote for your favorites now until Thursday lunchtime.
Oh,
and
lunchtime
then
at Thursday.
In the afternoon, all eyes on you.
I hope so. I would love it if 3D Printing Nerd won this. It's fun to win things.
Sure.
But I really want to thank you for letting us come to the show and help tell the story of additive, and really, I think, kickstart. I know that I don't believe 3D Printing Nerd was necessarily the first social media presence, but I believe that, I think when we came early on, we were able to foster the community and get more people. Like everyone I say, come to Formnext. You have no idea how large this event is, how amazing it is to see all this stuff. And now, when I come here, I see 20 or 30 of my content creator friends here, like working with companies and producing video content and meeting fans and it's just amazing to see.
But it's all about the effort of giving additive manufacturing a broader reach. I mean, everyone is really motivated to get the word out, to get people motivated, inspired to take up additive manufacturing in one way or another. Whether it's at home, whether it is for professional work, it's all there, and it all helps in bringing the technology forward and bringing the industry forward.
You know, if we're talking about bringing the industry forward, I think means we should probably talk about the younger generation. And can you tell me what Xolo and Formnext do to get the word out to the younger generation? Are there specific events or activations here at Formnext that allow families or younger kids to experience this thing, this wonderful thing?
I mean, at the end of the day, Formnext is still a B2B event, so it's not a family event, and if you look around, it's not really suitable for families as such. At the same time, we would like to give young professionals a way of being included in the industry. We have a career day on Thursday, where there are job offerings, we have job consulting, and in Germany you need a photograph for your CV, so you get photographs taken.
Okay.
So that's what we do here on the Thursday. And if we have requests from high schools, universities, we always try to support them getting access to Formnext.
That's
There's
cool.
a really preferential rate for attendees from universities. So yeah,
well, I mean,
we try to support it as much as we can.
Yeah.
Yeah.
Well, families I know is a bit much, but I mean, anytime you can get the word out and show kids something really cool.
Yeah.
I mean, that's why a lot of kids want to be like policemen or firemen when they grow up, because they see these people doing cool things.
They're very present.
And helping people. And so kids naturally, I think, gravitate towards things that are fun, things that benefit others.
Yeah.
I mean, just, you know, because they're kids. And so it would make sense that.
And things that are cool. And additive manufacturing is cool.
It is
and
cool.
That is the good message, because there are some industries which are not as cool.
Christoph,
this one is.
This is really, well, okay, and I've said this to multiple people, additive manufacturing is mainstream.
Yes.
Or more so than it has been in the past. Okay, when you started, or when you were part of the Formnext back in 2015, obviously a lot of written content about it, right? But nowadays you have people here posting Instagram stories, TikToks, Snapchats, YouTube short form content, long format videos, like blog entries, photo journal, and like it's cool now. Like, it's mainstream. There are people using the social media networks to do really cool content about all the stuff here.
Absolutely.
Okay, so for Formnext, obviously next year, 10th year anniversary. This, I know we got to get through the rest of the days here, but
free to go.
But what do you have in mind for the 10th anniversary of Formnext?
It's not, well, we don't have a fixed concept as such. We will definitely have some sort of celebration. We always have the big party on the Thursday night, so that's a must. And we will have some activations leading up to Formnext 2025, but also at Formnext 2025. What exactly? I'm not quite allowed to say yet. We're working on it. It's not fixed, as I say, but we have some ideas, and we would like to make a good party out of it.
Yeah, it'd be fun. I mean, that's the celebration. I mean, that's an industry celebration.
It is, yeah.
Bringing it here.
And there's so many players as well who are with us along the way, be it as an exhibitor, but also visitors. So we would also like to figure out who joined us from the very beginning and stayed with us until now, until next year, and we'll have a little something for them.
There's probably some interesting stats out there of companies who have been at every single one, because there are companies.
There are.
There was 200 in 2015, right?
Yeah.
Okay, so a certain number of them are here today.
Yes, they are.
Do you know any off the top of your head?
Yes, but no, that's too early to say. Let's keep it until next year. I know that there's definitely, we did a check, and it was a 3-figure number. So yeah,
that's huge.
That's huge. That was the analysis of last year. So we'll figure out now who joined us this year and also next year, and then we'll.
I know some have mentioned the word contraction within the industry, and I mean, I know that has happened or is happening, but at the same time, if we're talking about people that have been here since the beginning and it being a 3-figure number, especially when we talk about it was 200 at the first one, while the industry is contracting, we're still seeing some very massive successes within the industry.
Absolutely, yeah. I mean, they're mostly larger corporations, but they're also young startups who joined us 2015 for the first time, the first splash at Formnext 2015, and they're still here. So that's also a good message.
Oh, that's cool.
So there are some. We'll release the list
Okay.
shortly.
Christoph, an important question. Once Formnext is over, and you're not wearing your suit and tie, and your pocket square, which we'll talk about in a sec, what do you do to kick back? Like, this is a, like you said, a B2B event. We have people that are busily going to all of these booths and lots of deals being made, and you and your team having to oversee everything. When the deals are done, when the event is over, and you're sitting down, what do you do to kick back?
Kickback. Well, first of all, there's a bit of sort of typical German boring red tape to be done after that. And then after that, we're straight back to the drawing board, straight back to work.
You don't take any time to like have a bowl of ice cream or something?
Well, ice cream, come on, it's almost Christmas. Maybe there's, I don't know, some Lebkuchen and Stollen or something. No, of course we'll unwind.
Okay, good.
No, there's time to take, but I cycle a lot. And December is not really the best time.
No, not unless you're like south of the equator.
Yeah, exactly. No, it's really muddy and cold. And
well, Germany, temperament, the temperature and the weather is very similar to Seattle. I think it's similar latitude, right? And so in Seattle, it's cold and wet. And in Germany, it's cold and wet.
Cold and wet.
Cold and wet.
There's snow forecasted for this week.
Is there really?
Here, yes.
Has it snowed at a Formnext conference before?
Lightly. I think it was just sort of light snow.
Yeah?
But it didn't lie on the ground.
Well, because it's forecasted for Thursday.
Yes.
And Thursday's the party, right?
Yes. Well, we don't have to go outside. That's okay.
Well, do we go outside? Do we go have fun in the snow?
Well, if there's enough snow, yes.
Yeah.
Snowball fight, no?
Of course.
Yes.
You know, I've used 3D printing to make a ducky snowball maker.
Oh, really?
Yeah.
Okay.
And
I didn't know that. Okay.
oh, yeah.
Did you bring it?
No, it broke. I used it a bunch and then it snapped. It's fine.
We can fix it here, I'm sure.
But I think that's an interesting idea. Like being able to, like if it starts snowing, we have a few 3D printers here, and we can have all the manufacturers get together and create snowball making devices.
Catapults.
Sure.
Catapults.
Trebuchets.
Yes.
Ooh.
Sounds interesting.
That's a
I
catapult,
think
but
we
with
need
glass.
to go back live on Thursday evening, maybe.
You know, I did a YouTube short about the Ducky Snowball Maker, and it got 26 million views.
Wow.
26 million views. And that's,
Did you release the blueprints for it?
well, I mean, they weren't mine. I
Okay.
said, here's where you could get it.
Yeah.
But I think that's really cool to talk about. It's cool. It crossed over into the mainstream.
Right.
Like it was cool enough. It was 3D printed, just like with Nike making their Air Maxes now, or that university back in the States that did the biggest 3D printed boat. Like it's hitting the mainstream, which is kind of fun.
exciting.
Is there anything at the conference that you've seen? Because let's see, is today Tuesday?
Yeah,
It opened.
it's the first day.
First day, right?
Yes.
Yeah. Yesterday was just the
I haven't
cleanup.
seen an awful lot. I just walked, so but carry on.
That's what I'm wondering, because there's so many halls. A lot of people say you can't see everything in the 4 days.
Barely.
Is 4 days too short?
Oh, but 5 days is too
Yeah,
long.
Well, yeah. But, I mean, you understand why I would ask
of course,
this,
of course.
right?
Now, of course, you have to have a shortlist. If you come to Formnext, it is a huge exhibition. You need to have a shortlist. You have to have an idea of what you're looking for. Otherwise, it's just overwhelming, and you probably leave unsatisfied. It's probably not exactly
that makes a lot
the
of
best
sense.
experience. So, yeah.
Have you been to Seattle?
No, not yet.
You haven't?
Not. No.
Okay. You should come. I mean, you'd recognize the weather.
Yeah, right at home.
One of the things, though, I'd love to show you is what we've done with additive manufacturing in our studio space, because while we do production there, we also have ourselves a print farm and we do manufacturing.
Yes, I saw that. That's amazing.
And I think that I want to get your opinion on this, because it makes sense for what we've done, because we've been in the industry, we've made lots of content about it, we've produced video content about it, and we have enough machines, and now we've acquired more, we've purchased more, and we have ourselves a print farm. and I hired my wife to run the print farm, and she's currently
She's at home
she's
printing
at home
away?
printing away.
Okay,
Yeah, she and my daughter's boyfriend are the employees, and they work on the shifts. Who goes at what time to pull prints and start prints and
they
stuff.
get a good salary though?
Yeah, of course.
Of course, good. It's
I-
important.
Of course,
Yeah,
of
no,
course.
Just ask.
But I'm not the only story in that. I think we've seen additive manufacturing empower a lot of small business creation. And as someone who's been on the industrial side of that, how do you think this push for people with consumer level 3D printers having small businesses, do you think that benefits the industrial sector?
I believe so, because again, it's just getting the word out there. If you get more people in touch with additive manufacturing, be it with a proper industrial product, or maybe just something small, just to get that spark, I think it helps the industry as well.
Oh, okay.
Because my daughter, by coincidence, I didn't do anything, but she received a little, what's it called, like where you collect your money. What's it called?
Like collect the money like a bank?
Yeah, like a little bank where you
Oh,
put
just
in
a
coins.
a coin bank.
Coin bank, yeah,
Yeah,
that's
yeah.
what it's called. So she received that from her aunt, and it's 3D printed. I
Is
didn't
it?
I didn't ask for it. It just happened to be.
Wait,
and
did she print it or did she buy it?
the aunt? She has a friend, a young boy, a young gentleman, who is printing away in his in his room.
So he made it,
He made it.
gave it to her aunt.
Yeah, and
Who
she
then gave
gifted
it
it
to her.
to my daughter.
Oh, that's
That's
cool.
very nice.
Look at that.
And now she has a 3D printed coin bank in her room. Great stuff.
Is she interested in 3D printing at all?
Not yet. Not
Okay.
yet. We'll get to that.
Do you
a
have
little
one at
bit
home?
later.
Do you have a consumer machine?
Not yet. Sasha and I always keep talking about we need to get one. We need to get one, but it didn't happen yet.
I mean, it's a good year to do it. There's a lot of great machines.
Which one do we get? It's a political question, so you need to be careful.
It is, really. I mean, there's a lot to choose.
Yeah.
Every single one I've seen here is great. All right.
We'll see.
We have enough time for one more thing.
Yes.
And it's the pocket square.
Oh, the pocket square.
Can you take that out, please?
Sure.
So at
There it is.
Formnext, it's important that you wear the technology, or
Yeah, a
you
little
incorporate the technology.
Well, you have
And-
your shoes.
Well, yeah, let's see if we can do this without breaking
Exactly.
myself. So I got the shoes. You've got
A pocket square.
a pocket square. Now, talk about that a little bit.
Well, as you say, we wanted to have something to wear, some 3D printed product that sort of identifies us as the Formnext organization team. So we had to talk about textiles. Last year we had a special showcase on textiles. There was
Can I
a
pick this
symposium.
up?
Yes, please. And then we talked away to some of our colleagues and exhibitors, and this was printed on a Stratasys machine.
Right, I recognize this because they've done some fabric 3D printing for me as well.
Indeed. And then we talked to a designer in Milano on our press conference, and they have a small industrial design agency or company called White Label, and they helped us with the design. And you can see these sort of what's called like little grooves,
Yeah.
which outline the folding mechanism. So you fold it like that, and then you stick it into your pocket.
Oh, that's cool.
It's really quite nice. And of course, it has our logo on it.
Of course, it should.
It has to.
It
has
should.
to have, yeah.
Well, Peter, can we go camera one? Oh, sweet. So then what I would like you to do, because we're out of time, but I want you to tell everyone how they can find out more about Formnext. And I know they're going to watch my videos, but beyond that, what's a way that people can get informed and maybe participate?
Yeah, I mean our focus is, as I say, industrial. So if you're interested in the industrial side, then please feel free to subscribe to our newsletter. It goes out once a month. There's some stories, application stories from the different industries, which are fantastic to get some inspiration. And of course, subscribe to Joel.
Yeah,
That's another big
absolutely.
recommendation.
Yeah.
And together we will push some content out and get you motivated to come to Frankfurt next year for the 10th
Sweet.
edition.
That'll be fun. Christoph, thank you, my
It's been a
friend.
pleasure.
I
Thank
really
you very much
appreciate it.
indeed.
You should take this with you,
Oh,
or else I might steal it and take it home.
Have a good show.
Yeah, thank you very much.
Catch you later on. Thanks a lot.
Bye, Christoph. Hey, that worked great. Oh, thanks, Peter. What do we got here? Wow, that was Christoph from Misago. That was kind of fun. FDM Pocket Square would be cool with that fabric mesh technique. That's true. Someone may have done that, actually. That was from Adam R. Distribute, I was really looking forward to Formnext Chicago, but just found out it was canceled for next year. Yeah, the dates and the timing didn't work out. I believe they're still trying to make it happen in the future. So just, I guess, keep informed. If it happens, then, I mean, I'll tell you about it, for sure. Andrew Rogers with a tenner for the Biergarten Fund. Feeling donk, man. That's great. Maker Mind Next, it's good to see you, my friend. Jose Ferreira. Hi, there we go. Wow, this has been fun. Good job, Christoph, look at you. He's off stage, having a good time. Jeez. Next up, we've got, David, next up, we've got something pretty incredible.
Yes, we do.
Do we need to strike the table?
Yes, we do.
All right,
Hi, everybody.
there we go. There we go. Lars Hansen voted, thank you. Don't forget, the Formnext Ambassador Award. 3D Printing Nerd is nominated, you should vote. There's links out there, I've posted them on various social media networks. Rapid TCT in Detroit is the same time at the Formnext Forum was supposed to be. That's true. Yeah, I mean, if you're near there, you can always go to that. Joseph Carver, hey. Hey, what's up? This is cameraman Peter. That's his phone. Thanks, Peter. Danette as he hired a wife. Yeah, my wife, not a wife. What?
Ready?
Yes. Here, Peter, I'm going to give you that. Where do we, and we're just going to stand right here?
Mike's hot.
Oh, okay.
Oh, next up, we've got Anouk, correct? Yeah, come on up, come on up.
Hey there.
Hi. So
Nice to meet you.
Nice to meet you as well. If you could tell everybody out there why we have you here on the stage.
Yeah, I am a Dutch fashion tech designer, so I combine fashion and technology, and I've been doing so for 22 years. And
22
yeah,
years.
long time. I'm an old
22
lady by
years.
now. Yeah. But I have with me a 3D printed dress that I printed on Elegoo 3D printers, and it moves. So I wanted to show you.
Yes, so this is a dress, 3D printed, using
Servo motors, and so yeah, it uses an PETG.
PETG,
Yeah.
servo motors on Elegoo printers.
Correct.
And we have it on a model, right?
Yes,
And what's
yeah.
our model's name?
The model is named Larissa.
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 Did I
yes.
say that right, Larissa?
Correct, yeah.
Okay, good. You have a good accent. I want to make sure I
From the
emulate
Netherlands,
this.
yeah.
All right.
So that's good.
Do you want to bring her up?
Yeah, Larissa, you want to come here? So,
Hi.
this is Larissa,
Hi.
and yeah, she's wearing a 3D printed dress, but it also
Oh, look at
moves.
this. It's out of PETG and it's moving.
Yeah, correct. So what I
Can
have
you
is
talk a little bit about the design of the dress? Because without the 3D printed parts, it looks like a typical dress form.
it's a black dress.
It is,
little,
yeah, okay.
Little
It
black
looks,
dress,
it looks like
yeah.
a little black dress, yeah.
Correct, yeah.
But it's
Yeah.
got wings or flappers or.
Yeah, correct. And it is also open source, so you can find this on my Instructables channel, so you can make your own robotic dress.
It would be blue if
It
I
would
did.
be blue, yeah.
But it's
Yeah.
the robotic parts though. So just servo
Yeah.
motors, and there's a battery pack somewhere.
Correct, yeah,
And
in the
then
back.
do these, are these timed or do they react to sound? Or
Currently
I
they're
guess-
timed, but she has a proximity sensor, so normally when people come into her personal space, then it starts to basically move.
Starts
so
to
it's good. It
shoo
starts
'em
to
away?
flap.
Is
Yeah,
that right?
correct. Yeah. So here I have the
Oh.
part. So this is basically the mount that the motor is in, and then currently there's this part goes on it, and then you can basically
okay.
animate it.
Oh, this is just a
Yeah.
simple little servo.
A little servo, yeah.
Yeah.
So everybody can make it. It's not super fancy. It's very affordable to make, and you can start your own robotics project with that.
And you have an Instructables channel that
Yes,
actually
correct.
goes through the process of
Yeah,
talking
and you
about
can make
this.
it yourself. And they also have different kind of mounts to it. So in this case, this is not secured, but you
Okay,
can.
I'll hold it upright
Yeah.
just to make sure. But
So
I
here-
see. So
yeah.
then it would.
So you can basically, if you want to have a feather dress, we can do this, and then it can also start to move as well.
Oh, that's cool.
Yeah.
And really, your only limit is the number of these that you have. So you could place these
All over.
the dress.
Yeah, correct. Yeah.
Is it
Yeah.
comfortable?
Yeah, very comfortable. I feel like a superwoman.
She feels like a superhero. Yeah. So that is basically the idea, and what I want to do is get more people into the field of wearable robotics, to have more people, because I think it's a really fun field, and I hope that more people will join it.
It's really interesting to see this sort of take off, because a lot of people love to show, self-expression is key in this, and being able to design these things that give people more of a sense of self about what they're wearing, I think is so important. And it's powered by 3D printing.
Yes, 3D printing and electronics,
And super smarts from you.
Yeah, correct. And it's also the start today of the Women Empowerment Program that I also do with Elegoo. So that's also one of the other reasons that we want to get more females into this field, because it's it's a fun field, and we want to get as many females as possible involved in that as well.
I did hear about that though. Elegoo is doing more of a woman forward or woman empowered sort of effort, and this is a part of that, right?
Yeah, correct. Yeah.
Can you talk about the machines that these were printed on?
Yes, this is the Neptune series. So the parts are printed on the Neptune series, the Pro and the Max I used for that.
Okay.
So so it's pretty easy. They're affordable, and again, everybody can just start really easily. Using these printers, and really affordable pieces of electronics. So
for me. The 3D printing isn't something that I'm worried about. I've done 3D printing a lot.
Yeah.
And I understand how to make these parts and what they're printed on, and they look great.
Yeah.
And you're wearing them great, good job.
Thank you.
But the electronics can be a little bit confusing to some.
Yeah.
I do have a little bit of an electronics background, so I understand it, but I'm always trying to mention the concepts when I do electronics projects, just to try to bring more people in.
Yeah.
What are some of the ways that this project can really demystify electronics for people that might find some anxiety around it?
Some of my other designs are a little bit more complicated. They also have to do with like machine learning. What I wanted to do here was really easily combine a servo motor movements, and kind of that's it, sort of, So you can pick up any Arduino, any 9G servo, and as you might know, they're a few cents.
Yeah, they're not expensive.
Money, sort of, And that's the fun thing. I think things like Arduino are really easy if you want to learn to program, learn to code, and all of that stuff. So picking up an Arduino is always a good thing, or any kind of mini computer that you can use to kind of program and to start like an animation, an LED blink, and then go from there, So.
Okay. That's really cool. So being able to not just use servos, but LEDs and the other aspects of what the
around the body,
offers.
but also think of body sensors. You can use your heartbeat, you can use brain signals. There's all kinds of data around the body that we can use, right? So
that's fun. Oh, human body data powered clothing.
Hey, yeah.
So then, so what are the next steps for this for you? Because you've been doing this for 22 years, and you have an engineering background.
Yeah.
And I would imagine this is not the end of what you're doing. This is just a stepping stone.
Yeah.
And what are the next steps for you?
Well, I like to work sometimes for companies. Sometimes I like to work with makers, like putting out instructables. Like, how do you make this? I'm also an educator myself. So for me, it's important to not only learn things yourself and make things yourself, but also share it with the world. So for me, open source is one of the ways to do that. So most of my projects that you can find, you don't only see oh, that looks cool, but you can also go on Hackster.io or Instructables and actually make them yourself.
Oh,
and I think
cool.
that is a really important thing of being a maker, is not only making it yourself, but also sharing it with your broader community.
That is one of the tenets of maker community is the sharing of the open sharing of ideas, right?
Correct,
the open sharing of ideas.
Yeah. So,
do you think projects like this could get companies who might not be typical for open sharing to maybe start open sharing?
I always ask, but always the companies that I work with, sometimes they're afraid, oh, we don't want to go open source. But I'm you're not open sourcing everything. You're open sourcing a really small thing that you can maybe get closer to certain communities yourself, and it's just a really nice gesture. So I think open source is just a really fun thing for also companies to look into, to get closer to their broader communities.
I think so. Yeah. Well, and if we talk about open source and companies doing this, if we kind of loop this in, I kind of had an idea.
Yeah.
So
Tell me.
something like this would really work as a 3D printing project.
Yeah.
There's a lot of companies right now that are putting together projects where people buy a box, and in the box is the hardware and a link to the files to print, and then they put it together and they do the thing.
Yeah.
But for something like
Hackathons and
this,
such
for
things, yeah.
hacking your clothing, you could put together clothing hacking kits.
Ooh, yes.
And then you would preload the Arduinos with whatever sketches or whatever code is needed
Yeah.
as an example, and then people would just print the parts themselves, put
Yeah.
it together, and then be able to attach it to their little black dress or
Yeah.
whatever other
Like
clothing
a kit
they're
of
wearing.
things, sort of. Yeah.
That might be a neat
Yeah,
way.
it depends. Also, like a fabric for a jacket is different than a fabric for a dress, of course. But
Right.
I like your idea. Yeah, that's good.
I could
yeah.
be. I'm always trying to
I
think
like
of ways.
the modularity of things. So
The
yeah.
modularity is cool.
Yeah.
Because I've worked with some Arduino stuff.
Yeah.
I had a small Arduino board and it powered, I believe, a lightsaber.
Yeah.
So that
I
was
like
cool.
That. Yeah.
I didn't wear it, but it was still cool.
yeah.
Lightsabers cool. Yeah, see? Lightsabers are cool.
Yeah. Yeah. So yeah, but I think in general the field is called fashion tech. It's a really fun field. It's a really inviting field. Whether you're a fashion designer, an architect, or an engineer getting into this field, it's just really fun to work with things around the body, sort of, you know. So for anybody that wants to pick up stuff like this, pick up a 3D printer, pick up an Arduino, and start to play around.
Okay.
Sort of.
Well, you know, something like this is interesting because when we talk about engineering, and you having an engineering background here,
Yeah.
we talk about engineering, it's all about solving problems. And normally we think about things that are usually easily measured.
Yeah.
But when we talk about the body, for example,
Yeah.
it's very meaty and
Yeah.
squishy
Yeah.
and doesn't necessarily...
Flexible.
And everybody's not the same.
Correct,
And
yeah.
so I think being able to study the fashion elements, but applying engineering principles to it, I think is fascinating.
Yeah.
I think it's a way of being able to solve more problems.
Yeah, well, it's different problems to have because normally a product is boxed in and now it's around our bodies, right? So
Yeah.
that's kind of a funny thing with us. But fashion also from the other side, it's fashion is there to express us, right? Couture, it's something that we share something with the world, and that's kind of the fun thing of connecting electronics, whatever that is, motor, smoke, robotics. To the body and see where that goes.
It'd be really cool to add more elements to this. And
Yeah.
as more things happen than like smoke or lights, or that would be cool.
Yeah, yeah. So, but it's online. People can print it. People can print it out and start to play with it themselves. And I'm highly encourage them to do so.
I hope so.
Yeah, you can just connect it.
Do you, at home, what do you use? So I would imagine you have a drawer of electronics or a bin of electronics and wires and a soldering station. Do you have 3D printers at home?
I use my Elegoo 3D printers. I use other processes like selective laser sintering. And that's where I come from. And then I went to the desktop printer, sort of. Yeah, I've been doing 3D printing since 2005 around. So I had access to one of the first selective laser sintering machines. Now it's normal, but at that time it was new, sort of. And that was really cool.
Do you think that because the barrier to entry for 3D printer keeps getting lowered, costs keep coming down, do you think we're at a point where it's really going to empower more families and kids to learn about it thanks to like this sort of thing?
Definitely. When 3D printers were like $1,000, or you don't buy that for Christmas for your family or your children, but the printer that this is printed on is $180, like $180 sort of, you know?
Yeah.
And that's kind of a really cool present if you have 2 kids and you wanna, I always say like you can go to a store and get a thingy for your pencils, but it's never the perfect one, or you can 3D print it, you know? Because you can 3D design, 3D print exactly how you want it instead of buying plastics from a store, for example. And that's always the fun thing, how I explain it to children, you know, like, oh, there's something that you need, you design it, you print it, and you learn from that, you know. So I find 3D printers just really, really cool.
That's an interesting way to think about it, because a lot of times people need that first hit to get in, and it might be that they see fashion, like this project, and they're interested in it, but they don't necessarily think they can do it, maybe. But one of my first projects that really kind of kicked me into high gear, a part of my refrigerator broke.
Yeah.
And I remember thinking, like, I can't get the part, the refrigerator's old, I don't know what to do.
You need to look it up, and
so,
it's not in,
I started measuring and trying to approximate stuff, and I got to a piece that actually works, and it's still installed in the refrigerator years later.
Yeah, correct.
And so, this feels like almost like a gateway drug for 3D printing. Like, there's going to be people out there who might not want to get into it, but there's this really awesome project and they see you in your dress and how they might want to do something similar, and now they can do it.
Yeah. Well, before I talked that one time I wanted to wear something in the evening, and I 3D printed it in the morning, and I wore it in the evening. If I go out to shop for that piece that I really wanted, now in this case I designed it, I 3D printed it, and I had something custom, sort of, you know. And yeah, for you to find that perfect piece, whether that's online or you go to a physical store, versus you just make it, print it out, and wear it, sort of, you know. It makes things so much more fun.
So wait a minute. You set something to print in the morning.
Yeah, and I wore it in the evening to a party. Yes. Yeah.
Can you say what it was?
It was kind of like a neck piece that went over my shoulder, sort of.
Oh, it wasn't just like a small thing. It was a big thing.
Yeah.
Okay.
Yeah.
What did you print it on?
That was on a different printer, a Dremel printer that was like years back. So
okay, so during the SLS time.
Huh? Dremel, the 3D45. It's one of the other printers, but that was it was like 6 years ago or something like that.
Wow.
But so that was really fun. But that's showing off that it can be as hard as you can think of, as easy as you can think of, sort of. But you just need to start, and you just need to do it. Like, oh, heck yeah, I'm gonna. 3D print an element for my dress that I'm going to wear in the evening. Why not? You know, let's just try.
That's
and that is, I think, how you need to think of working with electronics, working with any of this stuff. You know, you just need to start with it, and you have so much fun in the process while making things. So,
do you think that 3D printing, as far as a technology, is going to be making entire pieces of clothing? So these are pieces that are attached to the little black dress.
Yeah.
Do you think in the future 3D printing will be making the little black dress?
Yeah, definitely. We even have a few of the girls at the Elegoo stand, sort of. They are 3D printing their physical fabric, like
the entire dress,
and they're wearing it. Yes, yeah.
Here at Formnext.
Yeah. But it's Chitta Kok, for example, she's walking around with a top and she printed it herself. So yeah, it's definitely possible. Yeah.
That's really cool.
No, it's good. Yeah.
See, my experience with 3D printing and clothing is the midsole of my shoes. And I didn't even do it.
Yeah, correct. Yeah, but even here at Formnext, you see already so many things that are applicable to fashion, to shoes. There are so many shoes here. Socket design for prosthetic arms and legs. I saw a few dresses. I saw a few shirts. You know, and that just makes me very excited.
What's some of the coolest stuff you saw here today? Is there something that stands out?
Well, I am into like the socket. I'm making prosthetic arms and legs partially as well. I designed them for a few people that I know, and there's some company, and I don't know their name, but they create the socket design and they 3D print it. And I've not seen that before because they do kind of carbon fiber on the outside and 3D print from the inside, which is a really small, smart thing. Because it's really a cool girl. Her name is Victoria Modesta, and she is kind of missing a leg, and she, instead of hiding it, she wants to show it. So she's making a lot of art legs. So I've been collaborating with her since 2015, and we put one leg. It has a small Tesla coil in the heel of her shoe, and there's a Jacob's ladder effect going through her leg, and you see it physically. It was for a product for Rolls-Royce.
That's really cool.
Yeah.
Like that's really
cool. So
not
only a prosthetic leg, but there's things happening. One, you step on it and it starts to smoke. So all kinds of things are happening with it. So
that's cool because it's gonna. A lot of times prosthetics were trying to mimic the look of a human leg or a human arm.
Yeah, but now it becomes also art.
But now people can do what they want and make a sweet Ninja Turtle arm, or
or you become a cyborg.
You become a cyborg and have a Tesla coil in your leg.
Yeah, correct. Yeah.
Jeez.
Yeah, so all kinds of fun stuff. Yeah. Again, you should join the world of fashion tech because
I guess so. I mean, as long as it's blue, like I said.
As long as it's blue.
It's good there. For this.
Yeah.
If you were to go a step further with what's happened here, with this dress, or what you printed, what direction do you think you'd go?
I think add more degree of freedom. So in robotics, we speak about degree of freedom. So more degree of freedom you have, the more you can do with it. This only has 1 degree of freedom because I want to make it easy and educative, sort of, But of course, the more degree of freedom you add to a design, the more motors you put in there, the cooler movements you can make, and such things, sort of. But I always make more versions of one dress. So this is the version 1.0, and in half a year it looks totally different.
Sure.
And,
once you get to version 6.5. It's going to look completely different.
Yeah, and at
right?
one point it's like how many, they're like children, sort of, Where are they? But it's, it's really fun.
Are you going to be here at the show the entire time?
Entire time until Friday, yeah. And I'm really looking forward. I already sneaked down at the metal 3D printing, so I'm super excited to see some of that, because last time I was at Formnext was 10 years ago. And it really grew, so it's really bigger now. So
it's huge now, yeah.
It's huge, yeah.
Well, yeah, Formnext. Christoph from Elegoo, who puts on Formnext, he was just up here before you guys came up.
Yeah.
And yeah, the first Formnext was 2015, 10 years ago.
Yeah. I was there.
And so
I was at the first one. Wow. Oh, I did not know that. I thought it was the
congratulations.
second. Yeah. So now I've seen it grown up. It's matured, and it's incredible. I love all the creativity. I love all the artists. Like, it's not only machines, it's the artists. Everybody's like walking around here, and it's really fun. Yeah.
This has been a lot of fun.
Yeah. You like your feather?
I've been playing with it the whole time.
I know, me too.
I'm just kind of fidgeting with it and playing with it.
Yeah.
And I don't, it's satisfying in a way.
Yeah.
And that's
so,
awesome.
So one of the only things, when we have still a moment, is what I still want to do when you're asking is 3D print feathers, because feathers currently, they sometimes these are ethically sourced, they're not plucked, but often they get plucked, and couture and fashion use a lot of feathers. So one of the little fights that I'm doing is creating the perfect feather, but as you're playing with it, it has so much how do you say that, liquidity sort of, you know, and that's sometimes a really hard thing to 3D print. But wouldn't it be cool to have the feathers be like 3D printed and kind of move like this? But that's one of the things that I haven't, the engineering riddles that I haven't solved yet. So might you know?
So you could, with 3D printing a feather, then make it either react or be a device that measures something. So if it hits something,
make
or
it sensoric,
make it a sensory experience, so that
build that also.
Especially
in
if
there.
it was on the dress, hanging off, as you passed by something, it would let you know you're too close. See?
Yeah.
It's like the curb feelers on cars, but, you know,
correct.
feathers.
Yeah, I have another dress that does that. But like physically printing of like the feathers to be like kind of as fluidic like this, that is something that I haven't tried. I try to print like a lot of different kinds of feathers in a lot of different machines. But that's always the fun thing about them, in a way.
I really appreciate being here. We ran out of time, but before you step off the stage, I want you to look into the camera right there and let everybody know where they can find out more and go to your Instructables page. Yeah,
you can find me under my name, Anouk Wipprecht, and my Instructables page or my Instagram is the same. So might you have any questions you want to get into this field, drop me a line.
Well, once the stream's over, once we're sitting down, I'll find it and I'll put a link in the description so people can go reference it. Yeah. Here, I'm going to hand you that.
Oh, thank you so much.
I'm going to give you one of these. Thank you for coming up with this.
And thanks, Larissa, for helping out here as well.
You look fantastic.
Thank you very much.
Oh, thanks.
Have a good rest of Formnext.
Yeah, thank you.
Nice day.
Thank you. Well, that was
What's
fun.
going on?
Dude!
You're strong, man. How are ya?
I am so happy to see you. You guys, it's Ivan Miranda.
It's me. So, how are ya, man?
I'm good.
Can you believe that we never met, ever?
No, not in person.
First time.
Not in person.
Yeah.
Oh my,
This is...
you're taller than I thought.
You are taller than I thought. And you're way taller than me. Yeah. How is it going, man?
Oh, this is great now that you're here.
Yes.
This is great.
Yes.
What are you doing here?
Well, I came to visit. I've never been to Formnext before.
Never.
It's my first time.
The level of machines that you build could actually have their own booth here.
Some of them. I've been teasing some of the manufacturers, telling that they are my moral rival. That like this, there is a feud that they don't know of between them and me.
Yeah.
Building big printers that can print big things. So yeah, but they don't know what I'm talking about. But I don't care.
You know, next year is the 10th anniversary of Formnext.
Oh, really?
So you could bring your marble clock here.
There is a mini version of my marble clock here.
Where?
In Prusa's booth.
Really?
Yeah. I made a mini version to bring here.
You make small things?
It's still not small. It's the mini version of the giant thing, so it's not small. That happens a lot to me. When I tell everyone that I'm making the mini version of this, they see it and this is still huge, Ivan, this is still huge. So, but yeah.
Okay. Well, I'm gonna have to go see it then.
Oh yeah, for sure.
Jeez.
Yeah, and take a look. It doesn't tell time perfectly because I had to finish it like last night in the hotel next to the airport. But
Oh,
yeah.
sure.
Yeah.
Yeah, it's the Con Crunch.
Yeah,
You've heard of that? Yeah, it's Con Crunch, but for the additive
exactly.
manufacturing convention.
Exactly.
Yeah.
And I brought it to myself because I promised them that I was going to bring it on my own. So
Did you drive or did you fly?
I flew with it.
Okay.
I flew with it.
You're
Yeah.
in Lisbon. No.
No, in the north of Spain. San
North of
Sebastian.
Spain. You're in Spain. Okay,
Yeah.
you're in Spain.
So, yeah.
I was close.
Yeah.
Ish. Yeah.
Yeah.
I really want to come visit your spot
You
sometime.
You should, yes. My workshop is big enough for the both of us.
Is it?
Yes.
Are you sure?
Yeah.
I just want to see your cool stuff.
Oh yeah, we could build something together.
Oh, we could. Yeah. Okay. Okay. You've heard it here.
Yeah, it's a deal. It's a
We
deal.
we are going to build something together.
Yes,
But then
yes.
you have to visit Seattle too.
Of course.
I
And
think.
I've been told by many people that in Seattle rains a lot.
It does.
In San Sebastian rains more.
Really?
It's like I think it's 20 days of rain a year more
Oh.
in San Sebastian than in Seattle.
Oh. I apparently we have a big machine coming on. So
It's coming. It's coming.
do you need a hand?
Are we going up? All right, we're going up.
Strong people.
Yes.
I'm just going to stand back.
I did absolutely nothing.
Okay. Is that going to work for you, Peter? Or is this too close?
No, it's fine.
All right, let's lock it.
Because this is live, everybody.
As you can see.
Told you that was going to be awesome.
Yes.
Okay. Oh yeah, lock all the casters.
All right. See you around.
I'm gonna get a drink of water. Look at, there you go. Tell everybody right there. Look at this guy. Look at this guy.
Look at me. Look at me.
You are live.
All right. It's live.
Could you hand me a water? Oh, just, all right.
Right. I will leave you two alone.
I appreciate you so much.
I talk to you. You too. I talk to you later.
I'm gonna get a sip and,
Sip it.
yeah.
We should now feel the silence. That's Joel
I like it.
like it.
All right, guys. Joel, there's no laser for this one. Keep going.
Okay. Next up, could you set that to the side for me?
Yeah, absolutely.
Oh, there we go. It's just nonstop here. Peter, can you see us? Okay, good. Hey there.
How's it
Okay.
going?
Remind me of your name.
Stefan,
Stefan, thank you. This is Stefan. And how do you pronounce the name? Is it Xolo?
this is, Xolo.
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 Yeah. We try to make it
Xolo?
unpronounceable for English speakers.
I mean, that X really throws you for a loop, right?
There we go.
But the reason that you're here is because you can print things really fast.
Really fast.
Like really fast.
really fast.
Okay. Can we print something really fast?
Let's do it.
Okay. Oh, can I poke the button?
Absolutely.
Which-
So, Marcus, are we loaded up?
Yep. Just choose the dance, select.
Choose the file. There's
Okay.
only two things to set up. That's speed and power. We
Oh.
already did. So you just hit print
Well,
button.
before I hit print though, speed is relative to what?
It's millimeters per second, per minute.
And energy is what?
It's the intensity of our light sheet,
Okay.
which is the brightness of the light sheet.
Okay. So millimeters per second and the brightness of the light.
Yes.
Okay. 3, 2, 1.
So now what
Oh.
happens is the cuvette is moving inside, and inside there is a light sheet.
A
that's
light
coming,
sheet.
Yeah, that's like UV light coming from both sides,
Okay.
shining into that cuvette. This is our build chamber, and the light sheet goes from both sides into this build chamber.
Can I hold that?
Absolutely.
Cal, baby.
It's volumetric printing.
I was
And
just gonna say this. I've been to UC Berkeley. Thank you. And I saw their computed axial lithography, which is a volumetric process.
Exactly.
This is not the Cal process, right?
This is not the Cal process. So instead of turning it, what they do is we move it in a linear motion, and we have the light sheet and then a projector. It's like DLP without layers.
Yeah.
It's
okay.
like moving DLP all the way through the vat. And that's what happens now. And you can see this is only printing for like 1 minute.
Yeah.
So we've already done half of it. Here you see the progress, and we're printing a pretty cool lens. And it's almost done.
What?
So what happens is now that
Wait. Usually with like a resin-based process, you expose a layer and you have to clear it from the film and then you have to bring it back down, but slightly not as far. And I know there are other technologies where you have to sink it into the liquid or whatever, but that like sometimes
We're done.
We're done. We're done. We're done.
Take it out. Have a look at it.
I do.
Just take it out. Pull
Just-
it up. See if you see the part.
Oh, I see it. It's.
Let's put it in front of this so
Will
we
that
can
help?
catch it in the.
Peter, can you see that?
Move it up a little bit, maybe. So this is a 3D printed lens. If you mill something like this, a prototype lens, you wait months. We print it in 1 minute.
This is a lens.
It's a lens.
Like
It works.
A lens.
It works.
Okay, so then.
Let's print something else, right? We still got some time here.
What?
You got another cuvette?
Wait a minute! Like this is.
It's an empty
this
one?
took a minute. This took a minute.
Yeah.
Okay, you're putting it in.
I'm putting it in.
Okay, now the build volume of this does seem to be rather small.
Yeah. So we took the small build volume. We can easily exchange it, right? We have different cuvette holders. We can put a 3 centimeter cuvette holder here, but we brought the small one for the
Okay,
show.
and that's fine. That's fine for the show.
That's fine
But,
for the
okay,
show.
so you can get a slightly bigger one.
Yeah.
Yeah.
But we would have to wait 10 minutes then. You don't want to do that,
10
right?
minutes. 10 minutes.
So let's choose another
Wait.
file.
Cross lens. Select print.
Let's
What's
take
next?
the thinker.
Oh, the Thinker. Sure. I know that's what they print at in the Cal Lab.
Yes.
They do the Thinker. So
Hit print.
yeah.
And it'll start. Just going to be in a couple of minutes.
So what are the use cases for this machine and the process that this is following? I know we printed a lens, and beforehand I had seen the lens that was printed. I haven't seen it being printed, but I saw the lens, we used it with a laser, and it did cool things. So, is this a lens machine, or
Yeah.
is there...
So these are the two things. Because we print without layers, we have perfectly clear objects, so perfect surfaces and perfectly clear objects. So we
didn't
use
even
it
think
for
about that.
we use it for optics, and we use it for bioprinting.
Oh, bioprinting, okay.
Yeah.
Oh, where no layers really comes in handy.
Yeah, you can put cells inside. You can print. It's super fast.
Have you printed with cells?
We've printed with cells. Yeah.
What'd you
yeah,
print?
yeah. Like some tissue, some.
Oh, it's just
certain-
like
certain-
something vascular, probably,
Yeah,
right?
exactly. And then the cells grow inside, and we're not moving anything here, right? The resin stays in here. It's not moving. It's not pushed through a nozzle.
Right.
It's not filled. So it's perfect for cells. They love it.
But a lens, like usually when we talk about lenses, they're glass and you have to grind them, and it's a thing. It's a process to make it, like photography, cameras, like what we're being recorded through. There's a lens on that, and it's
Multiple.
there's a whole bunch of lenses in there, stacked together, and those are all glass, and it's super duper expensive.
Super expensive, and you have to have a lot of lenses
Yeah.
because you're very limited what you can do. I envision that in some years we'll 3D print lenses for mobile phones, and because we're not limited to moldings, we can make much smaller optics, we can make better optics. That's the thing. So how far
that's-
are we here?
Oh.
40%, 2 minutes to go. Okay.
Oh, look at that.
Thinker is halfway there.
Do you have current customers?
Yeah, so this is mainly used in bioprinting for research institutes. So there's a couple of universities around the globe to print different types of cells and different
Oh.
structures and so on.
So that speed is really important for them to have, because they can get the pieces that they need to test nearly instantaneously.
They get it
as far
very
as their-
fast.
Yeah.
The cells are not being bothered too much. They have all design freedom. So they use it for bioprinting mostly.
Okay.
And then we have a couple of applications in the industry, which is mostly then optics.
Oh, I see. This really does
Yeah.
lend itself towards optics, but
Yeah.
yeah, if you're not disturbing the resin at all, like for cellular 3D printing, that's what you need, right? Because they're so wiggly and they're so fragile that you don't want to break anything. And
Yeah.
I know you can stick a needle into an alginate or whatever it is, and then kind of extrude stuff. But again, there's friction, and you're dragging something through a medium, and it has to float. And
You're pushing cells through a very
Yeah.
thin nozzle. They don't like that.
No, they don't.
And this is only light. You have the vat, you only push light through.
This is showing hollow, then it's still
No,
a solid object.
It's solid, yeah.
Yeah.
It's
Okay.
solid. So what we would need to do now is take it out and clean it. And that's about it.
Well, once it's done,
Once it's done.
what's the cleaning process for something like this?
It's the same as DLP, right? You take it out and you clean it in.
Isopropyl alcohol,
Yeah,
right? Yeah.
exactly. Yeah, it's the same. And the beauty about these optical things is there is absolutely no post-processing, optical post-processing.
Do you
needed.
have that lens that we were looking at before? We're gonna get you a lens. We're gonna see it. It's so tiny. Jeez.
Yeah.
Okay, Peter,
People are asking if the screen is built into the machine.
is that a good hold? Is that good?
Is that screen built into the machine?
This one, yeah. The screen is built in the machine, yes.
Oh yeah. Oh yeah.
Yeah, and the beauty is it's no post-processing, no optical post-processing.
Like you didn't have
no
to grind
grinding,
it further, or smooth
no
it or
smoothing,
anything.
no polishing. It comes out with nanometers precision optically.
Nanometers.
Yeah.
Nanometers.
Nanometers roughness
With no processing.
with no post-processing.
And it's just
out of the
like
box.
it's just going to get better over time.
Uh-huh. Thinker's ready.
Here's your lens. There you go. It felt
So-
good. It felt like a real thing.
You
Felt
want-
like a thing. Yeah.
You want to take out the thinker?
Yeah. Sure.
Let's see if it's there.
It is.
There we go.
Okay. That's.
Maybe
No.
try in
that's
front
not-
of the screen here.
Maybe.
Does that work?
No. Do we have a way of pulling it out?
Not here. Sorry.
Okay.
So that's how the screen works.
Does
Yes.
it? Okay. Bring it back. Bring it back. Okay. There we go. Oh yeah. Look at that. Let's see. Right.
There we go. Printed in like what, 4 minutes?
The audience is saying they can see it.
That's crazy pants. I'm just kind of rotating a little bit.
Yeah.
Oh yeah, with some light, I'm seeing it. Like it's detailed. Like what I see on this screen, it's it.
5 micron resolution.
Jeez.
Yeah, it's very, very detailed.
Do you ever accidentally put one of these in that you've already printed in because you can't see the piece very well?
We sometimes do it on purpose. You can overprint, no problem. You can print and then
Oh
you
my
put
God,
it
it's a
in and you
volumetric process.
overprint. Yeah.
You can overprint.
Yeah. You can put things inside and overprint. We've put a fiber and then printed a coupler on the fiber that was in there. Yeah.
Normally, when we have fibers and you have to attach a coupler, it's a mechanical process. Overprinting oh my gosh, that is a great idea. Did it work?
It worked. Yeah. And that's the beauty about this technology, right? It's a lot of possibilities.
Can I ask you what the cost is?
The machine starts at $85,000,
Okay.
which is reasonable for a volumetric printer. We do have a small machine that starts at 10,000, but we wanted to bring the big baby here.
Sure, you should. Well, okay, but before you go on, the price, but for a volumetric 3D printer, we have to remember the only time we've seen this before on the show is with the CAL process,
Yes.
which is not polished. I think it's fair to say that is not polished. It is a research project. This is a product,
Real proper machine.
a proper machine.
Yeah, and it can do optics, right? The CAL, you cannot do optics.
No, you can't.
It's for use for bioprinting. It's a beautiful process. We love it. This is just very different, like in a linear motion, right?
Yeah.
And then we use a special photo initiator that works with these two different wavelengths.
Oh, so you've got, it's 2 different wavelengths
Yeah,
that you're
so
using.
we have a light sheet from UV light and then the projector from visible light. And at the cross section of the light sheet and the projector is where the polymerization happens.
Really?
So we have a special photo initiator that is a dual color photo initiator. And by moving it through the light sheet, we can address every voxel in the resin.
Joel, I wasn't wrapping up. I have questions from the audience.
Oh,
And I
question
wanna
from
make sure I filter to you guys.
Oh,
because
let's do it, okay.
People are freaking out in a very good way.
Okay, what's the question?
First question from Andrew Rogers, what is the maximum build size?
Okay.
All right.
Can you ask that because my audience has
Sure. Okay, so question from Andrew Rogers. What's up, Andrew? What is the maximum build size you can do on this machine? I know you said that you could get bigger ones of these,
Yes.
right? So what's the biggest thing you've made?
So what you do is you take out the holder and you replace it with a bigger holder and you put a bigger vat on it.
Yeah.
And then you're just limited by the size of the machine, which in this case is 5 centimeters times 8 times 9.
Oh.
So that's the biggest size we can print with that machine. It's a little bit hard for us to go wider than 5, but we could build a custom printer that is even bigger in height and depth.
What is the limitation of going wider?
It's the light sheet. You wanna enter it from both sides and create a very homogeneous light sheet.
Oh.
And if you're too far, you
It's
won't
no
you
longer
won't get it that homogeneous. Yeah. So in X we're limited by the method. In Y and Z we're just limited by that printer, by that space. But yeah.
Oh, that's
can-
cool.
you can go
okay. Homogeneous light. It makes sense. Yeah.
There we go.
One more question.
Yeah.
This is from Thomas. Don't know how to say
What's
his
up,
last
Thomas?
name.
Your question's next. Here we go.
Roughness compared to optics from glass.
Roughness. Okay, so Thomas is asking, what is the surface finish or feel compared to ground glass?
Yeah, so we have a surface roughness which is incredible of around 5 to 10 nanometers, which is really optical grade. We were not yet near to what a real grinded lens is the shape fidelity. That's what we're heavily working on. But the surface roughness and it's super smooth and it's comparable to molded lenses.
Okay. Oh, really?
Yeah.
Okay. But we also, that's compared to the price to make a ground lens, compared to what is the price of the lens that I helped?
So the material is a couple of dollars, and it's in there for 1 minute. So
Yeah. Okay. That.
it's nothing compared to waiting for months
Right.
for a grinded lens, and then you can see if it worked. So that's a new thing.
Okay. Any more questions, David?
No, we're getting a lot of like, oh my god.
That's what we want to hear. The oh my
Yes,
gods,
yeah,
right?
A lot of that.
This is one of those things that really sort of blows the mind, because you don't,
Yeah.
there's steps along the way of additive where we talk about, I can't believe they can 3D print this now. I can't believe they can 3D print this now. Now we're talking lenses, optical lenses, and we're printing them. Well, not we, you're printing optical lenses.
And I mean, look at it like this. This is the toughest thing to print. Like, if you want to bend light, you want to be super accurate.
You have to be.
Imagine going into other industries like lighting or medtech, printing super smooth, printing with different material properties, because we can print high viscous resins. If you turn it, you see this is very viscous resin.
Oh yeah, the syrup is not able to move much,
Right?
is it?
Yeah, exactly. So you can achieve much different material properties. So there's really a new realm of applications opening up. But I prefer the optics thing. I just
The
love
optics
it.
things is cool.
Yeah, I love it.
Well, but I want to talk about the materials a little bit, because
Yes.
you just said by varying the what was it?
The viscosity?
The viscosity. Thank you.
Yeah.
By varying the viscosity, you can get different material properties in the end, right? What's your roadmap for materials? Like, do you have some things trialing that are going to blow the mind, or do you have some next generation things 5 years out that you're thinking about?
So our strategy is to demonstrate the technology and have prototype materials, but then give our photo initiators and our machines to others to develop new materials on it. So there's right now dozens of universities or research institutes developing new materials in bioprinting, in optics, in medtech. We have a project going on. I can talk about that. We just announced it. We print glass together with Swarovski. So we print glass-filled resin and then sinter it down to crystal glass.
Oh, one last question.
You're kidding. Hold on. You're kidding. That's insane. Wait, that's possible?
Yes.
Okay.
Last question.
Yes.
Can you overprint an opaque object?
Can you overprint an opaque object?
Oh yeah, absolutely. So the thing is, we print from one side, right?
Yeah.
And the part would cast a shadow.
Right.
So printing behind it will be difficult. What we can do is we print half, we take out the vat, turn it, and print the other half.
Oh, because it doesn't move.
It doesn't move. It's very viscous. It's just floating in there, right? There's no support structures. It's just floating in the viscous resin. So we just take it out, turn
I
it.
didn't even think about that, but like,
We can print opaque.
yeah.
So we can overprint
Oh.
anything if it's not too complex, right? You cannot print inside something crazy.
Right,
but
like a blind hole, right?
Yeah,
you
exactly.
can't print a
Yeah.
blind hole. But again, this isn't the machine to do that. You wouldn't do that with this machine. There's no reason to, because you're going to do it somewhere else.
that's already
For now, until you can print blind holes. I don't know. You guys
maybe that's the vision. then.
you're gonna discover some new form of light. You know, you're gonna be like now the new machine, it uses this new form of light then. Yeah. Like, this is fascinating. What do you do at home? Like, are you a mad scientist with a lab at home, or when you get home, do you like sit on the couch and eat a bowl of cereal and just kind of lay low for a bit?
Well, I definitely assembled my first printer 15 years ago. So I'm this tinkerer. I still carry a bag that I printed during COVID, like a little 3D printed wallet. But yeah, so this when I didn't found this company. I joined Xolo some time ago. But when I remember how I saw my first 3D printer, I was completely psyched.
Yeah.
And I had that feeling again when I saw Xolo, because what Xolo does with these resin printing is just so different than all these other methods
Right.
out there that I fell in love again, you know. So I really think this has a great potential, this technology. And I'm very happy we could show it here.
Well, I'm so happy you came here because I didn't even know this was possible.
Yes.
You know, a lot of, when we talk about, I know there's maple glass out of Australia. They can print glass, but also, you know, they're heating it to 1,000 degrees and
Oh, boy.
extruding it. So
Oh,
it's
boy.
not optical glass, it's melted glass. They're melted glass in a shape. Like if you were to 3D print with a glue gun, imagine that, but just really hotter and with glass, right? So, but this is glass.
This is glass down to 5 micron accuracy, and yeah.
So now
Very
explain
smooth.
that. So with Swarovski, right? You're sintering the print.
So what you do is you print a glass-filled resin that is like something 60, 70, 80% glass.
And okay, so glass being glass bead, like micro bead or
Yeah,
glass powder?
nanoparticles of
Okay.
glass inside the resin. You take out the green state, you wash it, and then you sinter it, which burns out the resin, and the glass shrinks. And then what you have is your pure glass part. And the idea is to get
I'm
that
sorry. I'm
very
sorry.
accurate.
Does it maintain the surface finish?
It does. It
No.
actually gets better
What?
because it shrinks, right?
I got 2 questions. If you want to do it.
Sure. Yeah, we got some. Okay, question time again.
This is from Joseph from Malta.
Joseph from Malta. Okay.
He says, how about shiny metals and reflective things?
Okay, so Joseph from Malta asks about shiny metals or reflective things. Can you print shiny metals or reflective things? So if you, let me see if I can figure this out. So if you had a nano-metallic powder in there, you would not, the light sheet has to pass through the material, so you wouldn't be able to do that. And so any opaque material you're not going to be able to print with, because the light sheet won't be able to create a homogeneous light through it.
That is true, unless the particles are smaller than the wavelength of the light. You might have a chance, but honestly,
Have you done it?
metal, no.
Okay.
And that's
Not
probably
yet.
the holy grail. It's going to be tough. It's not impossible,
No,
but everything
okay.
that's reflective, everything that's blocking and absorbing
Yeah.
light is going to be tough.
But you did say the words, if you had metal particles smaller than the wavelength of light.
Yeah,
Is that can you do that?
that is. There are these nanoparticles. They're very difficult to make. The process will be hard. Getting up the amount of particles that you need to get a proper part afterwards is going to be hard. Not impossible, hard.
So
But, I mean,
so next year.
next year.
Next
Yeah,
year
there we
when you
go.
come on stage here
with a metal part.
with the metal part. Yes. Okay. We shook
Deal,
on it.
deal.
It's actually happening. It's actually happening. Was there another question?
Yeah, and this is a couple people have mentioned this at some capacity.
Ooh, here we go.
So people want to know about generally kind of camera lenses or eyeglasses. Did you cover eyeglasses or camera lenses at all?
So the question is about camera lenses or eyeglasses. We've talked about smartphone camera lenses, right? Because of the size. Now, eyeglasses generally are a little bit larger.
Yeah, within the tolerance. So yeah, they are possible. And
because you just need a bigger holder.
you just need a bigger holder, and then you can print them like that, or
Yeah.
you can print them like that.
Yeah. Oh,
And if you print it
right.
like this, it would be like a 1 minute print for a set of glasses. We're not there yet. But
Wait a minute.
To be, but it's
So you
definitely-
would. But this is a thing. This is a thing. Okay, so normally eyeglasses are glass. If they're glass, they're sent away, made in a lab, they're ground to a prescription,
yes.
put in a frame, and sent back to you, and it takes time.
Yes.
Or they are plastic, or a plastic-esque lens that is molded.
Yeah, molded or grinded. If you think about complex lenses, like with different
Well, I've got
near
a mine are progressives.
Yeah.
Yeah,
So-
which
so-
is complex.
so there is like 10 steps of producing them.
Yeah, but like
This would print it.
it would totally print it.
Yeah,
You would
yeah.
just have to figure out how to model in a prescription,
Yeah,
right? Because you would need
yeah.
your software would be you would have software parameters that would define the characteristics of the model.
Exactly.
That's almost a business in itself.
There are so many applications.
And
that,
so you wouldn't
that
do
would
it,
be a business.
but a
yeah.
business would buy this machine and your photo initiator to then make lenses with it.
Yeah, maybe not that machine. Imagine another machine
It would need- well, yeah.
would be within the optician. He measures you, puts it in the software, it prints 2 minutes, washes
that's
2
the
more,
Future.
and
That's
you get your set of glasses.
That's the future. This is where 3D printing shines.
And then imagine there is a little micro lens array in there, and you can project on that and feed in information to your eye. I mean, there are all these ideas, right? If you have free-form optical possibilities, that's interesting stuff to do. Still to be developed.
do you ever just sit and smile, like knowing what you're thinking about and knowing the level of stuff that which you work with?
Yeah, it's a new thing.
Is it time? Okay. So I just got the word. We are running out of time, but before you step off and before we carefully make the machine, put it back and where you
Lift
can
it
roll
down.
it, I want you to look into that camera
All right.
and tell everyone where they can go to find out more about your machine and what you guys do.
So if you come to Formnext, come to Hall 11.1 and see us in the Berlin Pavilion. It's a huge red pavilion, and
You still got like 3 days.
we're here for the whole show.
Yeah.
And if you come and you say you watch the show, we'll live print for you.
Oh, look at that. Okay, but let's say they're not at Formnext. They can't get here. Where are they going to go? Let's say they're in Australia right now and they can't make the trip. Where are they going to go to find out more?
It's always worth a trip to Berlin, definitely. So our headquarters is in Berlin. You're always welcome to visit us.
What's the website?
Xolo3D.com.
XOLO.
XOLO3D.com.
XOLO3D.com.
There we go.
Dude, thank you so much.
It was a
This
pleasure.
was awesome. Oh my gosh, this was okay. So,
All right.
David.
Get it down?
Oh, we should probably close that, right?
Yeah.
Should we unplug it first, gentlemen?
No.
No?
Okay, we're
Okay,
gonna.
I'm gonna go from Bill. Are you lifting?
Do you want me to lift?
Someone needs to. From the front.
Okay.
Are we locked? Oh, wheels
Oh.
Casters off.
Is this locked
They're
as well?
lifting.
Okay.
Yep.
I'm gonna let you guys watch this. And you are down
There we go.
up top, man. Yes. Hot diggity. How was that? Let's see. I think this is this my water? This is my water right here? Okay, I'm gonna take a sip of water, you guys. Oh. We should probably put the table back, huh? I'm gonna sip. So everybody, grab your beverage or what's next to you and stay hydrated. Take a sip. Take a sip. It's a marathon, not a sprint. You want to put the table? Yeah, let's put the table back. I'm in. Oh, you're right. Oh, that was quick. Good job, Peter. Oh, thank you. Hey, everybody. David's right over there. NLTMW. Sounds like soon. Yeah. Prints the frame on another machine. Exactly. When we start talking about this technology, one machine prints the lenses and another machine prints the frame. That's perfect. Domenico, chug, chug, chug. Dude, I am thirsty. I am thirsty. Ian Reed, a sip. It's water. That is a sip of water right there. 3DP UK Tech Channel. Oh, thank you. Look at it. I even got more water. I'm just gonna keep that right there. Keep that right there. The networking guy. What's up? Hey there. Zombie Hedgehog. OMG, I just noticed the Polymaker booth. Yeah, it's right there. No, I'm in the way. Here. There we go. It's right there. There you go, it's right there. Yeah. That's good. Peter's moving the camera. I'm sorry, I shouldn't move, Peter. I feel bad. Someone normal, thank you for the stream from Taiwan. Domenico, the German aircon cranked. Yeah, for sure.
What are we doing here?
Oh my goodness! Dude, you made it!
Are you streaming?
No.
Oh.
No, just look at the camera though. You made it! Holy cow, did you sleep on the plane? Not even a little bit. I saw a picture, you look like Mike Tyson.
Yeah, so I stayed up all night. My wife came home for the night shift, and she was like, Ben, you didn't go to sleep, did you? And I was like, no. She's like, you don't sleep on planes. I was like, as soon as I land.
Yell at Joel's chest, because that's
Oh yeah, yell at my chest.
So, I haven't slept in like 30 hours.
It's good to see you, dude.
Yeah.
All right, we're ready for our next guest.
Are we?
Go get coffee.
Oh.
Love you all.
Oh, I love you.
Love you.
Well, that was Ben. It's Boy in Space.
Okay, your mic is loud.
Hey, Zombie Hedgehog member for 27 months. Thanks for bringing us the live content. Thanks for watching, and thanks for being a member for 27 freaking months. Thank you for the water. Who's up next, David?
Yes, with something very special.
Ooh, okay, Peter, here's this. We've got EOS. Come on up.
Exactly. Hey, Joel.
Hey, wait. Yeah, Sebastian.
Nice to see you.
I was trying to remember. It was
quite a while when we saw the last time. Do you remember the Hammer Challenge 2 years ago?
Yes,
That
that's
was
right.
awesome.
Okay, come here. This guy was, remember when I took the hammer and I hit it really hard and I got second place?
I guess so. Was it not the first? No? I can't
think it was
remember.
second.
It was
I think
quite a while.
I very distinctly remember it was not first. I would have celebrated even harder.
Cool, great to see you again.
Here, trade me spots. You get to take that spot. And now in front of us we have
what is it?
well, okay, if I'm here, let me just look at it. And it looks like a bug. It looks like, can I touch it?
Yeah, but be careful.
Okay, I'll be careful.
Very be careful.
But this is printed.
It is a Bionic Bee.
A Bionic Bee.
Exactly. Developed from the company Festo.
Okay. What does Festo usually do?
So Festo is also a German company, and they are focusing, or they are specialists in electrical and also pneumatic automation technology.
Oh, okay.
Yeah.
So they automated a bee.
No, so there is a, I think there is a bionic learning network behind, and they, are inspired from nature. They look, okay, what different animals are there, and what can they implement in a technical solution. And they looked, okay, in the bee and say, okay, how can we make a technical solution out of it, inspired by the nature, and then this was the result.
Oh, so this is an autonomous bee.
Exactly.
Oh,
and this is
okay.
also the first flying object that is possible to completely fly autonomous and in a swarm. So there is only one bee here, but in total there are 10 bees and they are flying in a swarm.
Oh, and they're all kind of communicating with each other.
Exactly, yeah. So this is the main story behind, and it was also the intention of this project.
Interrupting real quick, guys. Just trying to.
He's making sure Sebastian looks the best he
Well,
can.
also his mic was coming off here.
Oh, do a news tuck. Here, give me that. I'm gonna do it. Pardon me, Sebastian. I'm gonna do it. I'm gonna get it. I'm almost there. There we go.
Perfect.
There we go. Look at that. We did that. We're a team right here. So this can fly in a swarm autonomously with others. So they're all communicating and talking to each other.
Exactly.
But when we talk about the additive part of it,
Yeah.
obviously made with EOS machines,
Yes.
what specifically made the EOS machines make this able to fly?
Okay. So maybe you have to grab it again and see how light it is.
Yeah, okay. I'll be very careful.
Very careful, yeah.
And we can't fly it ourselves today, right?
Unfortunately, it's not possible, no.
There's some sort of German rule against the robots taking over,
Yeah.
I think. Okay. Wanna be
You can grab it.
very careful. Oh.
What do you expect? What is the weight of this bee?
So I expected it doesn't weigh much at all.
It is very, very less. It's a very lightweight design. What is your estimation? What do you think?
100 grams?
Really? Come on, that's less than 100 grams.
Is it?
It is.
I'm from the US.
Okay, I can say it is 34 grams. The
Are you
entire
serious?
34, it is.
So I was trying to figure out, I thought about what a 100-gram sample spool of filament weighed. And then I was putting that in my mind, comparing it to that. And so I thought maybe it was close, but 34 grams,
34.
That's far less than what I guessed.
Yeah.
That's nothing. That's nothing.
I give you another task. What do you think? So this frame is also 3D printed. This is the 3D printed part, okay?
Okay.
What do you think, what is the weight of the pure 3D printed part?
Just the 3D printed part.
Only
okay.
this frame here.
So the frame is. The rest of this is not.
This is not 3D
It
printed.
looks like foam. This is
Yeah.
fabric. Okay. Well, I think all the weight is going to be in all the extra stuff, and so the 3D printed frame, 5 grams.
Oh, very close. It is 3.
Really?
3 grams.
It's still less than what I guessed.
Yeah. But we started or the developers of Festo started with at the beginning of 20 grams, and then on a continuous improving process, they reached 3 grams, and this was also necessary to get properties that the bee fly like the real bee.
Yeah. Well, they had those constraints of they had to make it fly like a bee, right?
Exactly, and that was the intention, or this was also necessary to really have this lightweight design. But this is 3 grams, imagine.
That's nothing.
This is really nothing, it's nothing.
So what's the machine that printed this part?
So it's the EOS P110 FDR technology. So FDR is a short form for fine detail resolution.
Oh, okay. So if you want something with a lot of really fine details,
exactly,
you'd use this machine.
Yeah.
Okay.
So we introduced this machine, I think, 2 years ago. And what is the difference to the standard SLS printer? So we only applying 40 microns. And with the standard SLS process, we are applying 100 or 120 microns of a layer thickness. And with the FDR, only 40.
40. So this is 0.04 millimeter.
Exactly.
Whoa.
This is the layer thickness we apply.
Whoa. And is this a nylon material?
It is a PA11.
Oh, okay. So it has a nylon base to it, right?
Yeah, exactly. And also the spot size is also smaller. So the spot size of the FDR system is only 200 microns. 200 microns. Compared to our SLS or traditional SLS technologies is more, it's the double. It's for 50 microns. But with the FDR, we reduce the spot size to only 200 microns. And with that, we are possible to really print these tiny structures.
Well, when we talk about the spots, so the spot size of the laser that's doing the sintering process, right? A lot of times in the SLS process, if you're sacrificing super fine detail for speed.
Yeah.
Right, because a larger laser can sinter more, and you get faster parts, right? But in this, speed is you don't care because you need that fine resolution, that detail.
Exactly, and this is also the main intention here. We don't focusing on speed; we're focusing more on detail resolution.
That makes sense.
Makes sense.
I wish we could fly it.
Yeah, it's a pity that it's not possible.
Have you seen it fly?
Only in a video, but also not live.
Well, one of these things, it could be that next year at Formnext, we have a swarm of these performing in
That
the
would
corner
be great,
somewhere.
but hopefully we're also working hard on other applications,
Well,
and
other-
hopefully
yeah.
we can also introduce another application next year.
Well,
to
of
you.
course. I mean, that's the game. But I mean, this is a fascinating use of additive manufacturing because it's making something autonomous, an autonomous drone, for example, right? You don't have a lot of constraints. There's a general shape that you want to make it, but again, you're making something that flies by itself. But this one, having that constraint to still look like a bee, that presents some challenges.
Yeah, and also when we were designing the frame, it was also a generative designing approach the first time.
Really?
That is, okay, we would like to optimize the frame for lightweight design and also to have really a stiff structure that, during the flying process, there's no deformation. So that was the main challenge.
Oh.
So it's optimized for lightweight and also for a stable structure.
That's cool. Oh man, I'm gonna touch it again.
Do it, yeah.
I'm gonna kind of pick it up again.
Sure.
Okay. Look at that. Look at that. Peter, can you see that? Look at that. Look at that. It's just fascinating, Sebastian. Like
Maybe
when
from the size that also, we can also talk about the size. So the length of the bee, I think it's
well,
pretty
sure.
much
Give me some details
is
here.
200, roughly 200 millimeters,
Okay.
and the wingspan is 240 millimeters.
Oh.
Yeah.
So if we think about a bee, because I've seen them,
Yeah.
and I've looked at pictures of them, and the bee's wings don't look like this.
It's more like looking that they're looking like this, right?
Yeah,
Yeah.
they're kind of circular a little bit,
Yeah.
and okay.
But nevertheless, I think here the rotation or the movement of the wing is 180 degree, and
Oh,
also
really?
what is possible is that they have 4 degrees of freedom.
Really?
Yeah. Maybe when we're talking about the components, I think we have also here some little space. What components are in there? So
Well, I
there
see
is-
a little servo.
So there are 3 in total, 3 little servo motors.
Okay.
There is 1 brushless motor.
For
Additional-
speed. Usually brushless
Yeah.
motors are for speed,
Yeah.
right?
Then we have some PCBs.
Yeah.
Then we have the battery, of course.
Oh yeah, you need
And
that's, I mean, when we talk, batteries are going to be usually the most weight in some sort of autonomous vehicle, right?
Exactly. And that was also, when we did the design, it was crucial that we optimized it for lightweight, that we also have really enough space and also, for these components. And also, of course,
Jeez.
there are some gears.
Don't you just look at this and you're like, wow,
It is.
like wow,
And if you grab it, then you say twice, wow, wow.
wow,
It's
wow.
awesome.
Like man. What do you do with the machines that you have access to at work? Like we're talking about this bee here, but do you do personal projects?
Sure, yeah.
You know what I mean?
Yeah.
Yeah, because I'm always curious, because EOS, very industrial company, does amazing stuff, has incredible machines, does really cool projects, made me a really cool hammer. But like, I came into 3D printing as someone who had the consumer machines and then had more consumer machines and then visited Formnext and got to experience the industrial machines and meet people like you and be a part of the activation that you had. And so, do you use 3D printing? You know what I mean? You work here at EOS, but do you use 3D printing?
Do you also mean in my private?
Yeah.
I think I don't have to use it in my private life because I'm using it from Monday to Friday, the whole day. I'm dealing with 3D printing, and also we have access to the printers. So but I don't using extra 3D printing in my private time.
So you're printing all the time, but just not personal projects.
No. Unfortunately, not. There are, of course, a lot of customer projects, customer evaluating our capabilities in terms of materials, in terms of systems, and so I'm part of the Additive Minds team, and Additive Minds, I would say, is a tool to support customers in their complete additive manufacturing journey. So when they say they would like to evaluate the business case, we can do it. If they need support in some design topics, we can also support them. If they would have application development support, we can also do it. So we are a big global team to support customers, support sales, and really doing project work, supporting customers in their evaluation. And so we're doing a lot of different application development, a lot of different project work. So and we do also sometimes fun stuff like the hammer or the bee, but often we also do some customer-related project work. Yeah.
But it's good to know. Like, so 3D printing, you get to experience the wonders of it during the workday, but for you, you put 3D printing away when you go home and you get to do other stuff.
Yeah, exactly.
Okay. Well, Sebastian, what's your other passions?
There is only 3D printing.
Is that what it is?
I have a question. I might have this is for dealing with our next setup, but did you ask him why we need to have drones like this? Like,
I can ask, sure.
Please ask why. Everyone in the audience wants to know why, and they're also scared.
Okay. Well, okay.
And then we'll wrap up.
Okay. I don't think there's any reason for people to be. You got away on this passions thing because we got to move to something else. Say, for this, I don't think people say they're scared. You know, automation and robots taking over. But I don't think they should be scared, because what's the purpose for this sort of thing to exist?
Yeah. So I think the purpose was that the purpose of the complete project for the development was that there is a lot of inspiration of the nature. There is a lot of features that can be implemented in technical solutions, and that was based on the bee. But this is also something lightweight design, only to have such structures where the load is. So there is nothing more. There is only where the load is. There is there is some part, and I think this is also exactly what we can do in 3D printing, especially in laser powder bed fusion with polymers. We have no design, we have a lot of freedom of design. There are no support structures. We can nearly print every shape that we would like, and then we can also do some extraordinary stuff.
Well, I think there's just as I know we've ran out of time, but I think what you just said really encapsulates something really interesting about using that machine specifically, getting the high detail, low weight structures, being able to create this autonomous bee, but other autonomous vehicles that can be easier to fly because they don't necessarily have the high weight in the frame. Yeah. But I don't think people should be afraid. This isn't going to take over the bee's job anytime soon.
No.
Right?
It was only this demonstration to see what is technical possible, also including additive manufacturing. And I think this is a very nice piece to showcase what is possible. Also, what capabilities does Festo have? And then we can also implement this in other drone shapes, for example, there on the desk.
Sure.
Maybe you can give me for...
We can't, we're done.
Okay, we are done. Oh.
Well, okay.
So much things.
I know so much. Well, okay, so since we ran out of time, I want you to look at that camera and just let everybody know where they can go to actually watch a video of this and find out more.
Okay. So you can also visit our homepage, so www.eos.info, or you can also visit the Festo homepage, searching for the Bionic Bee, and then you also find more information about the entire project. And it was a pleasure to meet you.
Was
it
great.
was a
Good
lot
to
of fun.
see you again,
Thank
man.
you very much.
Next year, bring the hammer back, man.
I will do.
Okay. Here, I'm going to let you... No, don't leave that with me.
I will grab them.
Jeez.
Thank you.
Jeez. Oh, thank you. There we go. So the Bionic Bee, it is not going to take over humankind. I don't think we have to be worried. I think honey is still something that we're safe to have. Oh, we're moving the table.
Just stay where you're at. Stay where you're at.
Okay.
Stay where you're at.
Spherux, go to meet the Linkster guys. Oh, I saw Linkster.
Peter, can you get us out of our approach?
Oh, I'm sorry. We've. we've got an approach here. That I guess someone just pulled up. Peter, I'm going to hand that to you. Hey.
How you doing?
We've let's see. Oh, there we go. I'm in frame now.
Table? Yeah, let's get it up there.
Well, a table here or table where we?
We can move the table back.
Oh, okay. Yeah. To the mark. Okay. There we go. I'm just going to stand over here. There we go.
Where am I standing?
I think you and I are like right here.
Right here?
Yeah, right here. Dude, what's going on, man? Look at this. Okay, this is Matt Denton. He's getting mic'd up, and this is his Lego bike project. Hey, hey. See, you should get mic'd up. It's fine. It's fine. Yeah, Peter gets some. Look at that. Look at that, and that, and that, and that. Sure. Come here, Matt.
Okay.
Woo. I am almost there. Ugh.
I know.
Sorry, Matt.
It's okay.
It's like we're at the
All good.
back at Star Wars, and they're
good.
keeping us from
There
saying
we go.
things.
Right.
There we go.
I'm good.
Are we good? Is he
Yep.
unmuted and everything? Let me look at your butt.
Let me look
I
at.
think we're good. Matt, say something.
Hey, hey. I'm
Yeah,
here.
there we
All
go.
right, okay.
You guys know Matt Denton.
Hey.
How you doing, man?
Good.
Now, as far as additive goes,
Yep.
you are famous for these larger-than-life Lego projects.
Lego inspired.
Lego inspired, because I was just going to ask
Yes.
you, has the Lego group sent anyone after you?
No. Do you know what? I just met a very nice man from the Lego group.
Really?
Yes.
And was he a fan?
I think that he's a fan of my work.
Okay.
Not officially, unofficially, of course, because this is not Lego.
Lego inspired.
It's building blocks.
It's
Giant scale interconnecting blocks
giant scale interconnecting blocks
Mm-hmm.
that you are not selling.
based on my childhood toys.
Right.
Yes.
Right.
Yes.
It's just, before we get anything,
Yep.
I want everybody to look at the
Oh, yeah.
Lego inspired hands
Right.
holding the bike up.
And then the Lego aficionados out there will go, well, that's not to scale because the hand won't fit around that part. And you're absolutely right.
Yeah.
But I wanted it to look like hands, so
Yeah.
yes, I've cheated there. That is
Yeah,
a
it makes sense.
non-scaled part.
That is
Yeah.
wow.
Yes.
That's
this is
how
a,
many non-scale Lego inspired parts have you made?
Well, this is a lot of Lego inspired. So
Well,
hard is it? Building blocks.
Building blocks, sorry, how many
this
building blocks that look like-
This is 8.34 times larger. Everything gone here apart from those hands.
8.34.
Yes.
That's very
It
specific.
is very specific because, okay, a real Lego axle, this part here, is,
Oh, that one in front,
is
okay.
4.8 millimeters in diameter. Okay? Now,
Okay.
for something like this, you have to add bearings for things to run in. So
Yeah,
you can't
of
just
course.
put plastic on plastic.
No.
So when you scale it up, there's a trade-off between how much you can fit on the printer and the size of the bearing that will fit through one of these holes.
That makes sense.
Now 8.3 recurring, 8.3333 multiplied by 4.8 is 40 millimeters. And you can buy 40 millimeter bearings.
Oh, perfect.
So I scaled it, I just rounded it up to 8.34, and that's why it's that scale.
That's enough. Well, yeah, 8.3 recurring is
Exactly. It's
I
too
mean,
much. Yeah, so in
I mean,
CAD just 8.34.
Yeah. I mean, we are dealing with melted plastic, so we
right.
do.
Exactly.
We don't have to be so precise.
Exactly.
Yeah, we're not machinists.
Yeah.
Well, maybe.
Sometimes. Sometimes.
So the process for printing something like this.
Yep.
What machines? What material?
So this particular one, I've used Lulzbot machines for many years on many of my older projects. This one was actually using a bamboo P1S and Prusa XL for the
Okay.
larger parts. And this is all Polymaker material. I try to do everything in PLA if I can. So a lot of this was Polysonic and Polymax PLA. But there are some Polymaker polycarbonate parts like
Ooh.
the rear suspension here.
Okay.
Anything that's got to be tougher, there's some polycarbonate shims where pieces have to rub together.
Oh, it's good to have a shim. Yeah.
Exactly.
You don't
yeah,
want a PLA shim there.
Exactly.
Jeez.
So polycarbonate shims. Otherwise, it's all Polymaker PLA, which is my go-to.
They make great stuff.
They make great
They
stuff,
make
and they've
great
been
stuff.
supporting me for a long time. So
Well, and they're good people.
they are good people.
Luke's back there.
There
What's
is
up, Luke?
Luke.
There we go.
Luke Taylor, everyone.
You know, this is one of those projects where it's amazing, and I would want to do this.
Yeah.
Like, how difficult was it to do this?
So this one, which I think is one of, it's not easy to make, but it's easier
No.
than like the go-kart that I made, which is a lot of work.
The go-kart was a bit much.
It's a lot of work. And
It's a
you
good
can lift
one.
this one on your own. You can
Yeah.
actually just about lift this. So this would be, I worked out recently, about 400 hours of print time and about 35 kilos of material. Yeah.
Okay.
It's not terrible, but obviously if you only got one printer, 400 hours is quite a long time.
Yeah, that's true.
Yeah.
And what sort of infill are these pieces being made with, or how many walls? Or,
So
some of these extrusions look pretty fat.
Yeah, so I've got 0.8 nozzles.
0.8, okay.
0.8 I've gone with on this. 0.5 mil layer height. Most of it is, so I go with like lightweight parts. Let me see if I can get something off here. Hang on. Take the seat off.
Take the
like
seat
that.
off.
So that to me looks like, that's about 10%
Let me
infill
see
part
that.
because it was a seat.
There you go.
And then if I take this piece off, this was a 5% infill part.
Is that hard to see, Peter? Hey, you got it, okay.
And then, for example, the suspension arms here,
Yeah.
the swing arms, they are 3 perimeters, 25% infill, like 4 bottom, 4 top layers. So these these are pretty chunky. You know, when you fill them,
Oh,
they're
with a
hard.
0.8 nozzle?
Yeah.
Yeah,
So
those
they're
are
like-
those are chungus.
They're not
yeah.
going anywhere. Yeah.
And
But
then-
it's surprising what you can get away with, to be honest. I always overdo it a little bit because I'm trying to save weight all the time. And that's obviously a cheating part because the batteries sit inside of here. I don't know whether, if I take this one off, there you go.
Oh, there we
the
go.
battery sliding
You see
out
the battery
there.
back there, Peter?
You see this one? There we go.
There we
So
go.
that- whoop. So it slides, the batteries slide inside of the seat.
It's a big
And
battery.
then,
right
here we go. You can see it now.
there. Oh, there we go. Yeah.
Nickel metal hydride battery so that I could transport it on the plane. But
Oh,
it does
yeah.
use-
You can't take the lithium,
no,
can you?
but it does usually take lithium batteries. So let's get
Oh.
that back on. So in the UK, I have lithium set on there.
Sure. Does it go a little faster?
It doesn't go faster, but they go a lot further. So these batteries that are in there right now have got a quarter of the capacity of the lithium ones.
Oh.
So it's plenty good enough for doing
Yeah,
demonstrations.
just getting down
here.
there from the Polymaker
Exactly.
booth.
Yeah.
This has seen some screen time. Like didn't Adam Savage see this?
He did, yeah. On my second to last video, Adam was in town, and I was working at Shepton Studios on a film, and Adam came in to do a piece on the film, and he's a friend, and I was like, well, I've got this thing. Would you mind having a look at it at the end of the video? And he's like, yeah. And 5 minutes, we took it into one of the empty studios at Shepperton, and he had a little razz around on it. And as he put it, he'd pay $5 to do this. So I thought it was a little low, but you know.
Come on,
no,
Adam.
he was just teasing. He was teasing, but he
10
loved
bucks
it.
at least.
He loved it. Yeah, at least, yeah. But yeah, so it's it's gone down well, and I actually prefer it. I think to the go-kart in some
Really?
respects. The go-kart's terrifyingly dangerous now.
Yes, it is. No, I remember you and James, right,
yes,
were
he-
tearing around in that
Yeah,
thing.
he stuffed it into the side of the tennis court
Yeah.
and broke the chassis in two. This is a little safer, although the steering is terrible. There's no trail on the steering, so it won't
What does that mean,
self-center.
no trail?
Trail. So, steering comprises of rake angle, which is the angle of the forks,
Okay.
and where the axle is placed in those forks. And a trail makes
okay.
the front wheel act like a caster. So a caster will always keep behind as it pushes forwards, and it always straightens the steering up. So if you can grab a bike and you can push it by the saddle and the steering will stay straight.
Yeah.
That's because it has the correct trail. This has
okay.
negative trail,
Oh, that's not good.
which means it basically is inherently unstable.
Yeah.
So it is really janky steering. So it currently has a top speed of 10.5 miles an hour. I think 15 would be about as max as what you want to do
Yeah.
with
Anything
negative
about that
trail.
would be kind of frightening.
So yeah. And then there are 2 more parts on here which are printed by a company that you know well, PCBWay.
Oh, PCBWay. Ooh,
There's the rear light,
yeah.
look at that.
Peter, there you go.
And the front headlight as well. It's in one of their resin prints,
This is a resin print from PCBWay.
which is beautiful.
It's just gorgeous.
Lovely. Yeah. So there's a front and rear light, and that's the only bit.
I kinda wanna keep- I wanna keep this.
Yoink. And it's
Like,
back
it's a
on.
beautiful part,
It is lovely, isn't it?
and it has a good feel to it.
That's the weight, isn't it?
Yeah, it's
Really
the weight.
nice.
Although, Something like this, you could put Denton in letters across.
You know what I wanted to do? I was just talking to someone about this. I wanted to put logo in the font.
Yeah.
Right?
That's pretty good.
Logo.
That's pretty good.
We got a question from the audience.
Yeah, what's that?
I want to know why PLA instead of ABS?
Oh, this is a good question. So the audience has said, why PLA instead of ABS?
It's a good thing. The reason why I use PLA is partly for the green aspect of it. You know, it's cornstarch, obviously made from renewables and kind of biodegradable. That's why I moved away from ABS.
Industrially biodegradable. If you for some reason had to recycle this, you could grind it up industrially.
Exactly. I'm never going to do that, but that's why I do it. But in all honesty, I probably should have gone with something that's slightly better in higher temperatures, because you couldn't leave this in the car in the hot weather, because it's all going to start.
No, it would deform.
Yeah,
it would absolutely deform.
And it's so easy to print. So
but you're in the
lovely
UK, so there's no such thing as hot weather,
Correct.
right? Yeah.
Correct. Yes. So that's why I'm stuck with PLA for now.
But PLA is naturally stiff.
Yes. Oh, it's great for layer bonding and stuff.
Yeah.
It's really good for this kind of thing.
Yeah, and if you give it a few extra perimeters,
yeah,
not a problem.
On the first kit I ever did was the go-kart, but it was at 5x scale.
Okay.
It's a blue and red go-kart actually, and I did all that in ABS. That was my first, and then I switched to PLA and never looked back, because it was so much easier to print without enclosures and stuff like that, and the smell and the fumes, and so PLA all the way.
PLA is a good material. I don't think people realize
I don't get it.
How powerful of a material it can be when printed correctly.
Exactly.
Laying a 0.8 nozzle, throwing it out at 0.5, like that's it's like you're putting toothpaste down.
Exactly. Yeah. Exactly that.
So if someone wanted to do something like this themselves, if someone was inspired by not just this, but your other massive building brick inspired designs, how should they go about starting their journey?
Well, I taught 3D printing in an island called Palau in Micronesia for 3 months some time ago.
Is that why you're
Western
in Palau?
Pacific, yes. Well, one of the reasons. I went there and then I was like, have you ever had a 3D printer here? And they went, no. My friend worked at the college. I was like, right, I'm going to set up a 3D printing class. And the thing that I said is like CAD. You've got to learn CAD. That's the most important thing. And one of the best things to, once you've learned the basis of CAD, is to CAD a Lego brick, because it's parametric. You make a 1x1 brick, and then the CAD package can parametric, and just go, I want a 2x4 brick, or a 4x8, whatever you want. So I think that's one of the nicest things to do. Is just to grab a Lego brick, measure it up, and CAD it up, and print one out.
Well, and then it's kind of neat too. I mean, if they're making their own Lego brick as a CAD design, then they can then use that and print it to judge fitment against a real brick, and so they can actually calibrate their 3D printer as well.
Yes, and the tolerances are really tricky. I mean,
So
that is why actually it's easier to print at this scale. It's very hard to print Lego bricks at scale that fit Lego bricks, real Lego bricks. Lego-inspired blocks at scale that fit real Lego bricks. Whereas when you're at this scale, you can get the tolerances much easier. So I would suggest if you're going to do something, step up to 3x scale at least. Print that out and play with them. And
3 times, at least. Okay.
Yeah, most of my kits will print from 3 to 8x scale, and then the tolerances fail, because the tolerance doesn't scale.
There's so much space in between.
Yeah, tolerance doesn't scale.
Yeah.
So you can scale the brick up, but if your tolerance is 0.1 millets at a 1-to-1 scale, you can't scale that tolerance. You still need 0.1 tolerance at 10x scale, because you need the same friction fit. So.
Oh man, that would be. You got to kind of.
So you have to have it as a parameter. Yes. Yeah, and you play around with it a bit.
So then all of these parts that you printed, you had to adjust for fitment.
Correct. So I go along, I print a few parts out, I test them, I then make sure they're fitting. And generally speaking, I've kind of nailed it now. I've done so many, I kind of know what will work. But there is a slight difference between my 8.34x scale stuff and my 3 to 5x scale stuff.
Okay.
A little bit, yeah, a little bit. They do get a little bit loose on the bigger you go. So.
And then, but you're not relying on the fitment to hold this together. You have some actual mechanical.
There are some
joints,
mechanical,
right?
Yeah. So there's some steel inside the front forks here. There is a steel encapsulated part in there. There is no glue on this yet. There are some bolted sections. The front forks frame here.
Okay, yeah.
There's a couple of bolts that come up through to join these two parts together. I could glue some of this, but to be honest...
And now, is this a self-designed part right here?
No, this is a real Lego part. Yeah, this is an exact copy.
Really?
Yeah. Which is why it's got terrible rake angles.
Yeah, I was just going to say.
But I did have some bolts in this, but to be honest, there's one long bolt that goes all the way through here, and I put it in, and then I quickly realized that once this part is on, you don't need it, because this holds all that together anyway.
Oh,
you don't need the bolt that goes from top to bottom. So actually that could come out. So it's doing nothing now, you know.
Well, it's just keeping it together.
Yeah. So, and then the only other thing is the pegs. I've put an aluminium bar that goes right the way across the pegs.
I mean, that's where you're putting your feet.
'Cause that's where you're putting all that load.
Yeah.
So I put some decent support in there.
Yeah, because if you go over a bump or something and your feet go whoosh,
I know, exactly.
you're just gonna
Exactly.
you're gonna rip those off.
But the exciting part, when I tested this, I was thinking that obviously when you're sat on the seat, you're pushing the force down through the springs and into the rear here.
Yeah.
So there's no way it's going to come apart. But when you stand on the pegs, you're putting all that force down through the rear wheel, and that wheel was pushing that force up through the springs, which could eject the seat, because there's no longer any weight on it. So that was an exciting part, was riding it and standing up on the pegs for the first time. And nothing happened, it all stayed together. So. Do you see what I mean? So you're putting 80 kilos of weight, in my case, or 85 kilos, down in the middle of the pegs, and all that force is being pushed back up through the forks and the rear suspension.
Right.
So why doesn't this just eject the seat and everything else with it? So yeah, but it didn't, and it's just friction fit. So yeah.
Okay, I didn't expect that.
Yeah, nor did I. I thought it was going to explode on me.
Yeah,
But,
that's
I'm
what you
sure
would
if I bet if I did a jump and I landed on the pegs, yeah.
It would.
It would explode. Yeah.
I don't want you to do that. I don't want you to possibly ruin it.
Everybody wants me to jump it. I tried to wheelie it the other day, and I nearly pulled a wheelie on my last video. Right at the end, I nearly got it.
With a lithium battery, right?
Yeah.
Yeah,
But
yeah.
It was really close.
Oh, was it time? Oh,
Yeah.
apparently
That's it.
we are out of time. But that camera right there that's in front of us.
Yep.
Go look there and talk to everybody really quick and tell them where they can go to find out more about this project and what you do.
Okay, so please follow me if you don't already on youtube.com/Matt Denton, that's MattDenton. And you can find me on all socials under Mantis Robot, @Mantis Robot. Do follow.
There we go. Matthew.
Thank you.
Thank you, my friend.
Thank you. Good to see you.
Good to see you. I guess, David's going to get the mic. You got that for free.
Buy me a drink later.
So then we just need to bring this down.
Help me out with this.
Come on, Luke.
We'll take it in one go.
There we go. Hey, dude.
Hey, man.
Oh my gosh, get up here.
Hi. He told me not to come bug you.
Oh, you should. Look at this guy. Frankly built. Now come around here so people can hear you, because you have to yell into my chest.
Where's your chest?
It's right here. See?
I love this man.
It's right there. It's right there.
He's beautiful. Is it this one or this one? Which one?
It's this one or that one?
He's beautiful.
Wait, it's that one? Is that one? Is that one?
Don't
Okay.
forget to like, comment, and subscribe.
Like, comment, subscribe. That's right.
How you been?
I've been all right. Look at this. Frankly built, the 3D printed nerd.
The 3D printed nerd. I forgot about that. Oh, yeah. You stole his moniker. I didn't know his moniker.
Dude, people are crazy.
I know.
How you doing?
I'm doing good.
How's your time at Formnext?
This is so cool. I flew in this morning at 9 a.m. I am tired.
Yeah?
Yeah, my flight was
You
fine.
just came right here.
Yeah. My flight was delayed from yesterday, the whole thing. So I flew overnight. I'm dedicated. And, well, they paid me, so I had to be here.
Yeah. Well, and now tonight you can sleep.
I would love to sleep, but I'm still trying to figure out what shenanigans. There's like after parties. You know.
Oh yeah, there's always an after party. Multiple after parties every night at Formnext.
Well,
we're on that camera.
We're gonna figure it out.
Hey,
Yeah.
there's so many people around us.
I know. I love it.
Okay,
it's
talk-
all. You get to hang out with your friends.
Dude,
That's the
talk
best
to me
part.
about this.
I wanted to put it on you.
Can you?
Yeah.
Okay, do it. Well, I mean, it's got a big battery pack.
No.
Okay. Will it fit my head?
I don't know. You got a big head.
No. That's no. We need the
We need
XL,
help.
the
I need
XL
to print
Iron
him
Man
A
suit.
bigger helmet. Why you got? It's all that beautiful brain you got.
Is
there.
that what it is? It's the beautiful brain?
Oh, wow.
Sure.
We did our best.
You know what?
What?
Thank you for trying.
I
appreciate that.
That's fine.
Maybe that's how we work together. We make an Iron Man helmet that fits me.
I can make you like an Iron Man helmet that looks like your logo or like in your colors.
Ooh. Well, yeah, but I want to make it with you. I want to
You
know.
can wear it with me. We
Yeah,
can come
yeah.
to these and like walk around. Like I have the full
Oh,
suit. It's already
yeah.
broke. It's kind of broke. I was gonna try to wear it. Like
Don't-
I was gonna like hop on stage in the suit and just mess with you. but
Yeah.
It kind of broke. So.
Don't. The 3D printed suits, aren't they a little fragile when traveling?
A little bit.
Yeah.
A little bit.
Like a little bit. Like,
Mistakes made.
yeah.
It's fine.
Like like every time you travel, you have to fix something.
You know, little.
Well, that's just battle damage.
That's me dropping it.
That's you.
Yeah. How are you enjoying Formnext?
I'm having a great time. This is amazing.
I know. It's just an excuse to hang out and geek out with all your friends.
It is fun to geek out with my friends.
Yeah.
It's really cool how many people I know that are here.
I know. You see people. You're like, oh, I know you.
Well, there's just like there's 15 people behind us. Just. I am ready for the next Frank.
Oh, I was not scheduled.
Oh, he just crashed. Give me a hug, dude.
Good
to see you. I'll be right back.
I'll see you,
You're here till when?
Saturday.
Perfect. We will see Frank. We'll get a selfie together later. Whew. Next up is, hey David, who's next up?
Hey.
Oh, hey, come on up. I'll switch your spots.
I'll
You
switch
get to
spots,
be.
thank you. All right.
Hey, I'm Joel.
I'm Stephanie.
Hi, Stephanie. Who do you work for?
Oh.
Well, or what are you bringing to us?
Yeah.
What is happening?
So, my day job, I am a full professor of biomedical engineering at the University of Victoria, so I'm like right across the way from you.
That's amazing.
Yeah,
Okay.
and we, my lab does a lot of bioprinting and printing tissues, and so we spun off a company called Axoloti Biosciences, which you can see.
Axolotl, like, okay, axolotls are the cutest things.
Yes, they
Like,
are.
Full stop.
Yes.
Okay.
And that's why they're our company's name, and my co-founder Laura is Mexican, so it was one of these things. They actually have a highly regenerative nervous system, and our lab prints neural tissue, and so we always were like, oh, this is our animal, because people study their nervous system, and we do neural work. So when we actually spun off the company, yeah, so.
So what do we have here? Like.
So I wanted to bring along a sample. So this is ultrasound gel, but it has the same consistency as the bio ink that we use to print our brain tissues. The ink we actually use to print the brain tissues is much more expensive, so you don't want to use
I
it.
wouldn't, like,
yeah, so
brains can't be cheap.
No, they're not cheap. And so this just gives an example of what it sort of looks like for normal people who don't always work with bio ink or have these capacities. So
It looks like a Jello shot.
it actually Cell Ink that makes bioprinters one year at one of their conferences, I think, did print Jello shots with
Did
their
they
printers.
really? Yeah.
'Cause
why not?
Because why not? Yeah, and so I mean, one of
Can
the
I hold
things, of course, yeah.
Okay.
So and I'm sure you're really familiar with traditional 3D printing,
Well,
right?
can I- can
Oh,
I?
yeah, it's ultrasound. You'll
Okay,
be fine.
Peter, you let me know.
Yeah.
I'm
So
gonna.
good.
This is neural tissue or an analog for neural
There's,
tissue,
yeah,
right?
this is what the consistency would be like when you print our ink.
This is not lime green Jello.
No, it's not. So we use ultrasound gel when we actually. So one of the things is printing structures. It's hard to predict what it's going to be.
I'm trying.
Yeah. It made it here from Victoria, so went underwent some pressuring and depressuring. We getting things up?
I'm afraid that I'm
gonna blow up. You
we
blow
are,
up.
We are going to have an event, right?
But that's fine. That's what Formnext is all about. This is my first time here. So, Dimitri, did he cap this? Huh.
I didn't see it.
Okay, well maybe it'll come out now. No. We're doing really good here, people.
Okay, here we go. Okay, so this is.
So this is what we do a lot of our test prints with to make sure that you get the right structure. Because unlike printing plastic where you can melt it, with the bio ink you should not melt your cells because they don't like that, they die.
No. But it's very viscous.
Yes, and so
super viscous.
And so we use this to test print. We have some that look just like actual brains that we've printed. We usually print half domes, and I know it won't show up on here, but if you wanted to see, this is what our brain tissues look like when they're going through them. So you actually print like a half dome. They have the neurons. They're sending electrical signals. They're doing all sorts of cool stuff.
There you go. Can I? Let's see.
Yeah.
Is this a? Okay, good.
Yeah,
Here we go.
it's a
Okay.
video.
Peter, let me know when you're on that.
Yeah. Oh wow, so it is showing up. Look at that. That looks really good.
There we go.
So yeah, this is a confocal, so it actually is taking images as you go through the Z-stack in our brain tissue. And it's just really, really exciting to see.
That's really cool.
Yeah.
Now let's talk about brain tissue, printing brain tissue. That's when we talk about we're living in the future, this really feels like living in the future type stuff.
Yeah, and it's really exciting. So we collaborate with a lab that works with Alzheimer's patients, and you can take patient blood draw and you reprogram their cells back to being stem cells, and then we differentiate them into neural cells and print them with our ink, and the brains we print, actually you can see the Alzheimer's symptoms in. So the idea is to actually use them to drug screen on.
Oh!
So you can, I mean, we could also do it with you and have healthy brain tissue.
Well, hopefully.
Yeah.
But you could, okay, so if you take blood from someone,
Yep.
and then you reprogram it to be stem cells,
Yeah.
and then you program it to be a certain other cell,
Yeah.
then because it's made from the same DNA, then you can possibly predict problems.
Yeah, and you can analyze, you can also do it with patient-derived tumors, see what drugs the tumor will respond to, and so it's really a way of doing personalized medicine.
That's really cool.
Yeah, no, it's super, super exciting.
So the process, now I know this isn't the 3D printing part, but how do you deprogram, or how do you deprogram blood to be back? How do you take blood and have stem cells at the end? Does that make sense?
Yeah. So this,
okay.
Don't worry, the guy who discovered this won a Nobel Prize for it.
Okay, good.
So essentially you express the factors that are present. So we all come from stem cells, and so they can become any cell type found in your body. So essentially you tell the blood cell to stop expressing the genes that make it say, hey, I'm a blood cell, and then you express the genes that say, hey, I'm a stem cell, and then it reverts back to having that property of pluripotency where it can become any cell type in your body.
You just tell it, hey, you're now this, or you're now expressing this.
Yeah.
And it's like, okay.
Yeah, well, and obviously it took a Nobel Prize's worth of research.
Well, I mean, I'm really sort of dumbing it down.
But yeah, that's...
Yeah. But then, so you have to go to a stem cell to go to a nerve cell.
You can actually also go directly, but most people go back to the stem cells because you can check their quality and make sure that they aren't going to cause cancer. We don't do this with our brain tissue, but there are people who use those cells for treating disease, like transplanting them back into the body, so you want to make sure that they aren't going to be problematic when you reprogram them.
So not just for like doing personalized drug development or looking for problems, you can actually take the cells that you've printed and put them in the body?
People, reprogrammed cells have gone back into the body. And for bioprinted, I think the ears from 3D Biotherapeutics was actually patient's own mesenchymal stem cells that you can isolate from blood. So you can
That's amazing.
So you can do this with your own cells.
That's just cool.
Yeah.
Like, I didn't know my blood was that cool.
Well, I think it's a really interesting project just because with our collaboration with UBC, we do have the patient whose cells we've used. So in theory, if we find something really that works for their type of Alzheimer's, it could be prescribed back to that patient.
Are you specifically targeting known Alzheimer's patients?
Yes.
I see. So then you're doing that and doing drug testing, and then if you're like, oh my gosh, this works so well, you can then communicate back to the patient.
Yes.
I see.
Yeah. And that's one of our really cool projects that works because our collaborators practicing Hack Night Guards are practicing MD PhD. So
that's really cool.
Yeah.
What do you think is the future of this?
Yeah. Well, I think. Not
that this isn't already the future.
Yeah. Well, I think one of the things I'm really excited to see. One of my colleagues, Mark Schuyler Scott at Stanford, he's doing an ARPA-H, one of those huge health grants to do a whole human heart. So for brain, because there's lots of reasons why you shouldn't print a whole human brain. We won't get into right now, but you can think about with the heart, even just from a 3D printing standpoint, you could, scan the person's heart if it was defective, and then use that as like the basis for printing a heart. Granted, you have to get all the cells and all the functionality correct.
Right.
But like that one makes a lot of sense in terms of, you need the structure and function. Same with like a lung, and so I think we'll start to see things like that.
Meaning that if someone had a failing heart, they could make a heart from their own cells.
Right, and also scan the initial heart, because another thing that's interesting, so your body's organs, they fit in your body, so being able to scan that and make a patient-specific match for some of the larger organs makes a lot of sense.
That's really cool, because then there's no rejection.
Yeah, so you can do it from their cells and actually physically fit it to them, because one of the things I find as a biomedical engineer really interesting was like the first artificial hearts were too big to go in women. And so that's why I'm always like, you can size them.
That's both. I understand, and that's really sad.
Yeah. Yeah. So I'm always like, so we could actually make them like to fit everyone's body. But yeah, there's a lot of really exciting work in the cardiac space. I know our collaborators at Aspect Biosystems over in Vancouver. They're doing a lot with Novo Nordisk to print, pancreases for diabetes.
Really?
So, and I've been, ever since they put the ears in people, I think people have seen that, okay, we can actually print stuff to put in.
That was like the test that kind of vetted it for people?
And also the other thing is just the regulatory. So, it's both, if you have a cell-laden implant, it's both considered a medical device as well as a cell therapy, depending on how complex the tissue is.
Really?
So yeah, it was like, and also it's still so new that there's like a lot of ground still being broken in terms of how you do
I guess that kind of
inventory.
makes sense, but to consider it a medical device, usually that's reserved for...
It depends on how complex you print the tissues, but yeah.
Still though,
I
like
know.
we're talking about organics. Usually a device is a non-organic, right?
Yeah.
Usually?
Yes,
Okay.
it should be, yeah. It just I think because it's still so new, they still are figuring out.
But that's
what-
cool to think about an organic device, right?
Oh, yeah, and I also think that, because I mean, it's also difficult to get just even a cell therapy, even
Sure.
without the bioprinted part in. So it's interesting to add in the additional things. But on the other hand, I do think it's a good way to address, things like heart failure, where you need all the things working together. So.
This is so cool to think about.
Yeah.
But you said you didn't want to get into it, but I have to ask, why wouldn't you print a brain?
Okay, so there's some people who think, and this, everyone, party trick, impress all your friends. So with us, with our brains, as I showed you, you can actually see electrical signals, you can see chemical signals.
Yeah.
And there are some groups that think with organoids, which aren't bioprinted, but they are, again, made from stem cell miniature brains, they think they're seeing brain waves. And so there's, I don't want to say a school of thought, but people are like, how would you know? Like they think if you make your brain organoids big enough, you're going to actually be generating human thought. And how would you know? And is it ethical to generate a thinking brain that's in a dish that's not attached to anything?
You know what? You have crazier problems at work than I do.
It's an interesting thing because people, we always talk about, and like, as I said, you see symptoms of Alzheimer's. So I do think we're like recapitulating things that occur in our brain. Do I think we're recapitulating thought? Unclear, but how would we know?
Right. How would you? It's just weird because you're guarding against possibly creating a thinking brain, a brain capable of human thought. Because how would you know?
Right. And so how would you?
That's nuts.
And so that's why they say don't get into so that's why there's always well, maybe don't make your organoids too large or put too many of them together, because then you might be doing this, that, or the other.
Oops, you might create life?
Thinking.
Okay.
Yeah.
Well, that's part of life.
Yeah, true.
Isn't it? I don't know. I'm not a...
I think there's I think you can actually run the whole spectrum on from philosophical, what is thought, to
yeah.
the neuroscientists, this is what the,
Well, there's some sort of checkpoint
EEG,
to go through.
EEG is doing thought, and then the philosophical of how would you know if the brain was thinking and creating memories.
This is
and stuff
fascinating.
Like that.
It's fun. I hope everybody out there is enjoying it as well, because I'm blown away. I'm absolutely blown away. Now, I mean, the 3D printing part's cool,
Yeah.
but being able to turn something back into stem cells and then something else and the drug therapies, your work sounds fun.
Hey, I am here to tell you neurotech is great. I think neuroscience is fascinating, which is why I work on the brain. We do run into some of these ethical things that, that you don't with a heart, where you're just we're making
But it's
hearts.
a fascinating ethical thing.
Oh yeah, and also how do you measure it? How do you quantify these different things? And so yeah.
I mean, there are guardrails in place because at some point in the future, something's going to happen.
Ethicists are trying to put
Right?
guardrails in place, so it'll be interesting.
Oh, we got a few more minutes
Oh,
here.
cool.
Okay, good.
Yeah.
Normally when we talk about neurosciences, we don't talk about 3D printing, which I think is fascinating that we're now talking about 3D printing in neurosciences. So, if someone who was interested in the neurosciences and also loved 3D printing, what do you think their next step should be?
Oh, well, I'm a biomedical engineer, so I think biomedical engineering is a good field, especially for people who want to get into the bio, because you need to also, one of the reasons why it took the field a while to evolve is it's a lot harder to print cells than it is to print plastic, so you have to keep them alive and deal with all the material science.
Yeah.
And people who make 3D printers usually come from a Mac electrical background, and so then cells are kind
That's
of
true.
compounding. So I'd say that, and I also know there's been a big rise with things like Neuralink and interest in neurotech. And so I think that's also a really good field to go into. So actually, I think the University of Illinois is the first school to offer just a straight up undergraduate degree in neural
Really?
engineering. Yeah.
Neural engineering.
Yeah.
Not the large language model neural networks,
No.
but meat space.
Yeah.
Neural.
Yeah.
That's so cool.
Yeah, and I know that my alma mater, WashU, they are also looking into doing neural engineering just because there's so many different components from doing things like a electric like a Neuralink electrode device, like what we do, where you need to have the cellular components. And honestly, we print physiologically relevant tissue. So it's almost like going back to doing histology, where you have to section them because we're printing physiologically relevant tissue models.
That makes sense.
Yeah, so it makes sense, but it's always interesting, like as a person who did her PhD in animal studies, I'm like, oh, to actually process this tissue, we have to go back to the old ways of making tissue, of like looking at it.
Then, okay, so knowing what you know, and with taking what you've told me, what do you hope to see in the next 10 years in your field with regards to what you can do now with 3D printing?
Yeah, I think one of the really exciting things, as I was talking about with the patient-derived stem cells and even tumors, like I think you'll start to see at the major medical centers, they'll have like a 3D bioprinting center, where if you have cancer, they'll biopsy you, they'll scale up your cell production in bioreactors, and they'll print a bunch of tissues and hit those with a bunch of different drugs to see what will be the best treatment for you. And I know that at least at the new hospital they're building in Vancouver, like I've been consulting with them on how to put together such a bioprinting suite. It is a bit more difficult and technical, so I think you're going to see like highly trained engineers running these types of machines just because of the complexities of printing living cells. And so I think that's something. I also think we'll start to see some of the work like with companies like Aspect, putting these tissues into humans, and hopefully we'll be getting some clinically approved.
Wow.
See that as the biomanufacturing goes. And also, yeah, the other thing is just like making enough cells to go into all the people. So we just got a bioreactor in our lab, so we're very excited to scale up our cell production.
Jeez.
Yeah, so, yeah.
Well, and what you said though, really, that personalized medicine, personalized down to being able to do drug testing, but not on the body.
Yeah.
That's fascinating.
Right, and that's what Axoloti, our company, is all about, because mice and rats don't get Alzheimer's or Parkinson's. So when you're making a disease model, it's very artificial. Whereas our human tissues are human, so they have much better relevance for trusting drugs that could potentially go into people.
Okay, so I want to thank you first for having this really nerdy discussion, because this was fascinating. But I want you to look at camera one right there, and just let everybody know where they can go to find out more about what we talked about. Either at the show or where they can go online because they're not here.
Nice. Yeah, so we have a booth down in Hall 11 in the Startup Zone for Axolotl. We also have our website, axolotlbiosciences.com. And you can also Google me as Stephanie Willerth, and that'll bring up my Google Scholar. We have a lot of open access papers on bioprinting if you want to learn more. And I've also done some other podcasts. And I do have, my second book just came out, The Handbook on Neural Engineering, if you want to learn more. And this has been awesome.
This has been fantastic. Thank you so much for coming by. This was so much. Thank you for the goo.
I know. Dimitri's going to laugh so hard about this. Awesome. And yeah, if you're ever in the area, I can show you all of our bioprinters.
You know, I'm in Seattle.
I know.
So I'm just a few hours south of you.
You're on the Clipper.
So that, I could just take the Clipper. Okay, I will.
I'll leave my card with your people.
I am so happy right now.
It's great, awesome.
I get to do bioprinting. Oh yeah, that's
nice.
I'm gonna put that down there. There we go. Well, this was cool. Zombie hedgehog. Okay, but what does it taste like? No. 3DHP, what's up, Jerry? Hey guys, hope you're having a blast. Hope you're having a good time, man. D-Shrooby, the worst part of printing a brain has been the post-processing. Sending out all those layer lines. Oh, that makes me laugh. That makes me laugh. Bearded printer, print all the things, including brains. I like a good joke, part of the fun, part of the absolute fun is the jokes. It's the jokes. I like the jokes. And on the seventh day, God cleaned his build sheet. This is awesome. Okay, so everything that you've seen so far, I hope it's been fascinating. We're always trying to bring you amazing, fun, technical deep dives at Formnext, because that's what you do if you were here. You would be able to visit these booths and talk to scientists and talk to engineers and deep dive into this stuff. And who thought we would be talking about neural engineering at Formnext? Like, this is an additive manufacturing show, and we're talking about brain hacking. 3D printing is cool. Zany Maker Zach, hey, it's great to see you at the event. Love seeing the energy, and the energy loves you. Pierre Moreno, Soylent Green.
Ready for our next guest, Joel?
Oh, is it? Oh, here you go, Peter. As said in the chat, our next guest is friend of the show and general lovely bearded person, Andrew Sink.
Hey, how you doing, Joel?
Dude, oh, come here. Come on.
All right, come on. It's good to see you again.
It's good to see you. Let's see, if I remember right, social media said you just got engaged?
I had just actually had my 3-year wedding anniversary.
Wait, was that? Oh, I saw an old post.
I know. It's my Twitter post. It says like, I just got engaged.
Yeah.
I should probably update that at some point.
I think someone, because every once in a while I'm shown an old one.
Every so often it pops back up to the top.
I thought you had been married. I thought you had been married. And so when I saw that, I was like,
interesting.
I don't know what's happening, so I'm just going to ask you live on camera.
No, it's all right. Every so often I get a congratulations post on that, and I have to say thank you. It's still going strong. Everything's good. Like, yeah, well, we have some pretty cool stuff here.
I am excited. So Andrew Sink works with Carbon. That's right. A very fantastic technology company. And just like that. Oh, and more, and more, and more, and more, and more. Oh, more. Okay. Hi. More. Anything else? Anybody else want to throw anything up here?
This is the time to do it. Like, we're piling this up.
We're piling it high. Holy
well, you said
cats.
you wanted to see some cool stuff, so I brought some cool stuff. We have a little bit of news that we want to share, but we should probably start by saying...
well, hold on. Before you share that news.
Yeah, of course.
Wow. Wow. Okay, share the news, please.
So really quick, my name's Andrew Sink. I'm an application engineer at Carbon. I work on our design team, and I help companies make stuff like this. And we just yesterday launched a new material called EPU Pro. And so this is EPU. Yeah, so this is a lot of the materials that you see here are EPU materials. That stands for elastomeric polyurethane.
Okay.
And so this is a 2-part resin with a dual cure. So similar to if you've ever done any pouring at home of like epoxy.
Whoa. TPU is thermoplastic polyurethane. Elastomeric polyurethane.
Exactly.
So it just doesn't have the thermal property.
Exactly. So it's a thermoset instead of a thermoplastic. Exactly.
Yeah.
You got it. You got it. Nailed it.
I'm gonna celebrate right
No,
there.
we got the shoes too.
Oh, here, let's see.
Oh gosh, that's not gonna happen. I'll do the one that's sitting down.
Come on.
This is like good.
Come on. There we go.
So, yeah, this is actually pretty cool. So this is our EPU material. Historically, it's been a 2-part resin. So you mix a part A, you mix a part B.
Oh, and then
you put it in a printer.
Science.
Yeah, magic. It's a little bit of both actually.
Yeah,
there is a little bit of magic in there. But now with EPU Pro, so we have condensed it down so it is a single-part dual cure resin. So you're not doing any paint mixing. You are not doing any dispensing. You have an extended pot life. If you've ever worked with epoxy before, it's like that. The minute you mix those two together, like the clock starts. Yeah, you start the timer. So the idea here is we're extending the pot life. So these parts here, a lot of these are EPU 41. We have some EPU 46. These are all of our sort of portfolio of resins for everything from energy return, if you want something to be bouncy, or energy damping, if you want something to do the opposite of bounce.
I learned about the 3D printed basketballs from another Andrew with 3D Gloop, and he talked about the coefficient of restitution.
Oh, interesting. Yeah, so it's interesting, right? You would think the TPU one would be bouncier.
You would think so, but the TPU it doesn't have the rigidity for bouncing back. It absorbs and exerts that energy as heat.
Yeah. It's the opposite.
Which is fascinating.
Yeah, and it's also like when you're playing basketball, when you dribble one of these, if you've played with the TPU basketball, you send it to the ground and it just stays there. It is not as much fun as it looks like.
The harder you throw it, the further it stays.
It's really wacky, and until you've done it, like
sense.
Yeah. So these are kind of the opposite. So this is an example of a energy return resin. So this is made for comfort applications. So this one right here is also bright pink.
Well, this is going to be.
This is the evolution. Oh, you got it.
Okay.
So this is the Ultra 4D.
Yes.
This is the 40 Forward 4. So this is the newest version.
Okay.
I'm rocking the parlays from about 2 years ago or so. These things have been all over.
Classic,
They're still working. And so this material right here, this is the EPU material with a sort of a direct coloration. So we can control, in addition to the pot life, in addition to the material properties, we have this sort of gradient of stiffness that we can control. And as a side benefit of that, because we're mixing the resin, we can also control the color, which is how you get some of these sort of interesting colorations.
Which, as an application engineer, is perfect for the people you work with because they want specific colors.
Of course. Of course, yeah, so we have Pantone swatches. So this is like typical, you have like a color palette you're trying to hit, and this is an easy way to hit it.
And talking about the energy return on this beautifully pink part that you guys hit wonderfully. I remember when I wore my first 3D printed shoe, or the midsole printed on carbon, I remember there was that energy return. Walking put a literal bounce in my step.
Yeah, you feel it.
Yeah.
It's pretty interesting.
It's weird when you don't wear this shoe.
Sure. It's like being on an escalator that's not moving. You're like, it's like great, it's just stairs.
Oh.
So yeah, so this is kind of, like this is an example of the direct coloration. We also have some saddles. So last year we talked about these. And
yeah,
so
that's right.
This one right here is the Aliante from Physique. So this just launched fairly recently. And last year we talked about making custom saddles. And we talked about, wouldn't it be cool if there was a way, because 3D printing is fantastic. It's great to make 3D printed products, but ultimately 3D printing for custom applications is it's like the perfect fit, right? Like if you're making something that's N of 1, why wouldn't it be something that's made just for you? And so the idea is now, this company, Physique, makes a custom saddle where you can sit on a pressure sensor. It takes measurement points at various points, and then converts those into data, which are used to populate the lattice. So each one of these saddles is different, which is kind of an interesting, like, you go to a bike shop, you bring your bike, you put the saddle on, you test it out, and then before you know it, you have one that's designed specifically for you, for your discipline, if you're a road cyclist or a gravel cyclist. Or if you're like me, you just kind of go to the grocery store and back, like it's perfect.
Well, I'm trying to think, if we talk about, so I'm not an avid cyclist, but every time I get back on the bike, sometimes, more often than not, there's been a stretch of time, and it's not just uncomfortable, but it hurts the day later, or my legs fall asleep, or whatever. But we can now, using 3D printing, customize the saddle so that I don't either, maybe that's mitigated.
Yeah, that's exactly right. So we're trying to minimize sit bone pain, which is exactly what you feel. So when you have your sit bones, those little hard nubs when you're sitting on your saddle.
Are those called sit bones?
They're called, it's officially ischial tuberosities, but that's kind of like a mouthful.
Sit bones.
Yeah, sit bones.
Sit bones.
Sit bones is easier. And those bottom out, and so you think you want a really soft saddle, and so you sit on it, and you sink straight to the bottom, and suddenly your sit bones are sitting on like a hard shell. Not a pleasant experience. So you want something that's just firm enough to kind of give you a little bit of support. And so that's where these custom saddles come in, because everybody's sit bones are in different places.
But using, you can scan or somehow acquire the data of people's sitting shape.
Exactly.
And then customize the saddle for that.
Yep.
It's just like a custom orthotic, but for your butt.
Exactly. Yep. And so it's a pressure sensor, so very similar. What a world, right?
An orthotic for your butt. I'm sorry. I didn't mean to distill your technology down to that, but
it is. There's a lot of that kind of stuff floating around.
Yeah.
So and then this is also a helmet. So this is a Riddell Axiom. So this right here,
this is the new
3D
one.
printed. This is the brand new one.
Yeah.
And so this uses. These are custom pads on the inside, and so this is energy damping. These move a lot slower. It's a really interesting experience when you deform them, because you press down and you'll see they kind of take a second to come back to their original shape. And so that's designed to absorb as much energy as possible. So this is something where you want linear impact, rotational impact to be minimized when you're being hit by a guy who weighs like 300 pounds and he's running very fast. So the idea is here, we can control where that energy is directed through the lattice on the inside of the helmet.
Protecting the brain is great, because I know football's a hard sport.
Of course.
Lots of hard hits, and you want to make sure people are protected. And but the energy return is a function of the material.
Exactly. So
which is like normally you would have to create a foam or a foam-esque thing, but this is digital foam.
Metamaterials, exactly. Metamaterials.
Yes.
So we try to control. We have you want to have two knobs really that you're really kind of dialing in, and one of those is the actual bulk material properties, and the other is the shape of the lattice.
No,
so different shaped lattices can do different things.
That makes sense. And it makes sense that, Riddell, a very large manufacturer of sporting equipment, and this is a large, like adult human helmet.
Yeah. This goes on the field.
Yeah. Oh, really?
And then gets hit. Yeah. I don't know what this logo is. I'm not a sports person, so this is maybe a question for the chat. If there are sports people involved,
chat.
Can somebody tell me what that is? I have no idea.
Get on that logo there, Peter. There we go. Okay. If we could find out which team that is, that would be great. That'd be great.
We're gonna find
out.
out
What I'm wondering
shortly.
is, it seems like technology like this would be wonderful for kids' sporting equipment.
Absolutely.
Like if we can protect the brains at a younger age, and not just in helmet sports, but that slow return energy for pads.
Yeah, of course.
For soccer, footy.
Shin guards, basically anywhere where
Yeah.
you have a linear impact, you want to try and reduce that energy before it hits the person.
Right.
And so that's where you have all of these tunable lattices. So it's, as far as I'm concerned, for additive, it's such a good fit because it's such an old industry, especially for sportswear, a lot of padding. It's just, a lot of this stuff is really, it's been the same for a long time. And there have been incremental improvements in foams, there have been incremental improvements in how we understand how this force is absorbed, but ultimately, being able to tune a metamaterial is what's going to make a big difference.
I think so. Dude, I think you're right. Well, and I think when you say you're an applications engineer,
sure,
it's not telling the full story. And I think it's really akin to, it's cool because as a company, Carbon isn't trying to sell everybody one of their printers, just go buy a whole bunch of these.
Yeah.
What they're doing is taking you and others and showing people how to use the proper material set and technology to make their product offering better.
I literally couldn't have said it better myself. That's exactly right. Like, you nailed it.
But that's perfect.
Yeah, exactly. So we're really not, I always say Carbon's a 3D printing company. We're not really a 3D printer company. In fact, we don't actually have a 3D printer at our booth this year. We just have a wall of consumer goods.
Okay, so at previous shows, you've had a printer not even plugged in.
Oh, it was plugged in. Remember, you opened the door with your foot.
Oh, that's right.
So it was plugged in.
It
But
was
yeah,
plugged in.
We typically, we're really focused on the printing aspect. And so what we want to do is partner with companies that are experts in their field. So I want to talk to companies that are experts in making football helmets, companies that are experts in making bike saddles, and then we're experts in 3D printing. We're experts in material development. We're experts in this latticing software. This is really where you get that, just like a fantastic product.
Well, okay, I'm glad you brought this up because this is a fantastic product right here. Let's just take this as an example, this Riddle helmet. But you or an application engineer worked with Riddle to customize this material, this metamaterial, for foam replacement, right?
Exactly.
Okay. How much?
Do you want to walk me? I'll walk you through the journey.
Is it more expensive than traditional methods?
So typically 3D printing is more expensive, but it
Yes.
can do a lot more than traditional materials. And so typically that's where, on an application engineering side, my job is really to understand what defines success. What is this thing meant to do? Is this meant to provide comfort? I turn the knobs. And so I'm really trying to understand what would be the best case scenario. What is the best product you can imagine? And then let's use technology to try and get as close to that as possible. And that's ultimately what I spend 99% of my time doing. The other 1% is doing fun stuff like this.
Okay. And so, I mean, there's that slider between legacy but cost effective and new tech but pricey, and so you have to kind of adjust that slider during the project development that you're working with a company on. And well, with safety, obviously lots of people say it's better to have the better technology because it makes people safer, but then people are like, it costs $100 more, and people are like, well, give me the old stuff anyway.
Yeah.
And so do you think, and I'm sorry to be so lengthy here, but do you think there is a world where carbon and metamaterial development is democratized a little further, where where you offer a solution to a company and you're actually like, for the same price, you get better?
Yeah, I think that's the goal, right? That's what we want.
Yeah.
That's what we're working towards. And in some applications we've achieved that. In other applications, there's still work to do. And I think ultimately, what we want is something that performs not just as good, but significantly better. And then getting the price down, that's the second half. That's the second hurdle, right? Like, we want to make it cheaper also. And so that's where the magic comes in. The magic part, that's the not cheap part.
Yeah, well, making it work and then lots of adoption equals cheaper product, right?
And we have some examples of some things that are sort of like newer in technology.
Yeah, let's see it.
as well. So this is the Puma Mostro.
Oh,
so
yeah, I was holding that.
This shoe was 3D printed in one solid piece. You can hold it if you like.
Thank you. Yeah, one solid piece.
One piece.
And it's crazy.
Yeah, super durable. So this is the same EPU material. It's also, somebody asked me if it was spiky. My answer was sort of. It has sort of like a reptilian kind of thing going on. But so this was designed.
It is reptilian.
It is a little reptilian. So it's a collaboration with ASAP Rocky, Puma, and then a couple of footwear designers to create a one-piece footwear. So this is a shoe you can just slide right on. That's made with the EPU material.
Well, maybe you, not me. I need a little bigger.
I wear jeans. Like, these don't look good with jeans. I don't know if I can pull them off. Like, I've seen people wear them and look good in them. I know that if I try it,
yeah,
this is not going to work.
Yeah.
I want them to work, but probably not so much.
I understand that. I hope one day I get to see a picture of you rocking
The
these.
fashion shoes, I will do my best.
Oh, tag me when you do, man.
So yeah, so these are cool. And then
The coloring on this, though, I know you control color. Is this post-processed color, or is?
Yeah, so these are painted, and then the detail, the black here, is sort of airbrushed on.
It is
And so
airbrushed
they
on,
give it,
okay.
Yeah, they give it a little bit of a pop.
But the red, it is base.
The material's actually, this material is black on the inside.
Oh, it
and
is?
Then it's, yeah, and then it's a red base, and then you have this sort of like airbrushed black on top.
Oh, okay. It's very, like,
Yeah.
I don't want to put it down. It's the, where are we on? Okay, we're on 2. I don't want to put this down. The feeling is so, it's like a fidget spinner.
Yeah,
but,
it's satisfying.
But, like, static.
Yeah. That's the energy return, because it bounces right back when you're playing with it.
It
So
does.
It's like, so
Okay.
on the more conservative side,
yeah, this is a bit.
this is a little closer to something I think that I could
look
pull
at
off.
that, man.
So this is also a one-piece shoe. So this is the Adidas Climacool. So this is made with a foaming material. So it's sort of like
It
a
does have that-
soft touch. Yeah, it's kind of like a novel haptic type feel. So it's very, very smooth.
It has a fur to it, like a fur,
Yeah.
not
It's
like
kinda
a very
like a velvet,
minimal, like
yeah.
like a peach fuzz.
Oh, I'm so glad I caught that.
That's a good catch, good throw. Yeah.
This is another example of the material. Same thing. It's a sort of like this leathery, velvety sort of matte touch. And so this
Yeah.
material actually prints out significantly smaller. And during that thermal cure, that second part of the dual cure process, it actually expands.
It expands.
It expands, which is where it gets that foaming. And so that's how you wind up with like 2 for 2. So this
Look
is
at you,
actually,
man.
I know, this never happens. I'm gonna drop it in a minute. So this is how big it prints
Yeah.
originally. Yeah, of course. And then this
Oh,
is
it's
after
super,
the bake.
like,
This one's super soft, yeah.
it's okay.
This one's squishy, so that's about a Shore 50.
Oh,
Shore
so
A50.
these are not the same materials.
These are it's the same base material. This one's had that sort of like that foaming agent added to it.
Got
and
it,
so you get
okay.
that nice kind of haptic feel. So this one right here is a Shore 50, and this is a Shore 70.
This is also comfortable.
I know, yeah. That's like because it's close to silicone, so it has that sort of like, hey,
It
nice,
is.
like very springy. And then I have something. I know you're a bit of a car nerd, and
Kinda,
so
yeah,
I
yeah.
brought like a car piece with me too.
Okay, let's see this.
And so this is the headrest from the Lotus Theory 1. So this is a concept car that was released recently, and we had the distinct pleasure of latticing the headrest, which has surround sound speakers built into it, and it also goes into a car that is built almost entirely out of carbon fiber. And as somebody who's not a car person, the first time I saw it, I thought, wow, I might actually become a car person. This is pretty cool.
So wait a minute, you latticed the headrest,
Yes.
meaning you got, thank you, meaning you took this form into software, latticed it.
Exactly. We call it a design space. And
Oh.
so the design space is the full 3D model that you're going to be filling with a lattice.
I see. And then of course you printed it.
And then we printed it.
Yeah. So then, does this go in that car?
This goes in the car.
Just like this, or is it covered with fabric?
No, just like that.
Oh,
You can
that's
rest your head on the
cool.
back, yeah.
Really?
Yeah, yeah. And so it goes right in the car. It actually snaps on right in the back.
See, more things like this, I think, need to be a part of our future. Like integrating electronics, speakers, stuff like that, but within a comfortable lattice framework. I would, like if the whole seat was like this, including the headrest, where I'm, yep. I want all of this.
One of our application engineers actually replaced the headrest in her car with a 3D printed one that she latticed herself. So
Really?
you can see, and yeah, it's funny, like you walk past it and you see a headrest and then you see the lattice one and you kind of slow down for a minute, like, when did this happen? This seems new.
I want a lattice headrest. That's awesome.
So that's what we're up to these days. So we're
That
working on a
is-
lot of parts. We're working on a lot of production equipment, and this is sort of, to me, this is what 3D printing is meant for. 3D printing is meant to print stuff, and I feel like
Absolutely.
we're doing it. And it's
You're
can go into
absolutely doing it.
You can go into a store and buy these. You can like go into a shop and like see them on the wall. I was just at the Adidas store in Frankfurt here, and they had a whole wall full of 4Ds, and it's like, yeah, that's the thing. It's 3D printed. That's what we're here for.
But it's really cool to see, like, there's plenty of manufacturers here at Formnext that bring the latest, greatest new machine technology, material, process, right? But then Carbon comes along and says, here's these products. Like you said, there's not even a machine at your booth. Here are the products we've made with our technology, our materials, our process. And I think that is a wonderful way to showcase cool stuff, dude.
Absolutely. Yeah, it's such a wide world out there.
I love it every time you come on here because we just get to talk about cool stuff and I get to squish things.
Yeah, it's
one
also
of my,
it's
one
also
of my
squishy.
pastimes is squishing things, and I just love it. Well, listen, a lot of people are going to want to know more about what we talked about, so look in camera 1 right there, and just let people know where they can find Carbon at the show, just in case, and if they're not at the show, where they can go to find out more.
We are at Hall 11-1 if you are at Formnext, and we are in booth D22, I believe. And you can go to Carbon 3D, and you can see we actually just launched a new website too. Carbon3D.com.
There you go.
Good catch. And we just launched a new website, so you can go see our resins and materials. And we also have a really interesting kind of page. We have our software, hardware, and then we have a product showcase. And so this is just a gallery of all the parts. It's just a hyperlink to all the stores where you can actually buy 3D printed things today with
That's
no
cool,
lead time.
man.
And so that's sort of like, that's the thing. That's the promise, right?
I love it. Dude, every time you come on, it's wonderful.
Of course.
Thank you so
So
very
good seeing
much.
you, Joel.
Andrew Sink, everybody. Make sure you follow him on the socials.
Enjoy the rest of the show.
And wish him a good engagement on the 3-year-old post. Yeah.
We'll see ya.
Oh, yeah, go that way. We got stuff. Oh, I'll let them take care of the stuff. I'm gonna answer questions.
Yeah, answer questions. Then we have something wild next.
We do have. The Coyote logo is generic. It doesn't belong to a sports team. Okay. That's still a good example of technology. Absolutely loving the coverage. Should have subscribed a long time ago. Hey, thanks for subscribing. Yeah, if you, now that you're subscribed, you're going to see a lot more stuff because we're filming a number of booths here at the show, and those videos will be coming out over the next couple weeks. Only if it goes into the flying cars that Gen X was promised. Exactly. Lattice all the stuff in the flying cars. All fun and games until your kids shove French fries in the holes. Hey, did that really? That must have happened. Bearded printer, another winner. That's right. Oh. Maker My Nexus, good to see you. Well, this is, I'm having a great time. And you're not going to want to miss the next things we have. We've got, I think we might have an exclusive later coming up, right? Peter shaking his head. Okay. Okay. Yeah. Huh. I'm going to hand the phone back because we've got some, as producer David said, crazy stuff. Actually, this gives me a time to drink water. Everybody out there, grab what you have next to you to sip on or to chug and take a sip. Okay.
Hi there.
Well, hello.
How are you? Please be careful.
Oh, did you cut yourself?
Not yet.
Hey there, I'm Joel.
Hi, I'm Daniel.
Hey, Daniel.
Nice to meet you.
Nice to meet you. My producer just said I'm going to cut myself on this thing if I touch it too hard.
No, it shouldn't be like dangerous.
It shouldn't be. It shouldn't be dangerous, David.
Here. It also doesn't explode.
It doesn't explode?
No, it doesn't explode.
Not yet.
It's aluminium, plastics, no explosives.
So this says Spherene.
Yeah, that's Spherene.
So what is Spherene? What do you guys do?
So we are a small startup from Switzerland, and we found and invented a minimal surface that is new on the market, and we patented it. And I will tell you everything about it right now.
Do it, yes, please, everybody.
All right.
Yeah.
So you might know like the TPMS structure gyroids for infill.
I do like gyroid. It's one of my favorites.
They look like that. Because of that, I brought some here.
Okay.
Gyroid lives happily in a cube.
It does, yes.
As soon as you want to make a sphere out of it, you need to cut the gyroid out.
Oh.
And what happens then? The outside form looks a bit different. It will be like more chaotic. You don't have these nice sine waves, cosines. Okay. Then the gyroid, if you press like here from all these directions, it's happily compressed.
Yes.
But if I go here, it's uncontrollable, as you see right now.
Right. It is a varying level of resistance depending on the corner you push on.
Yeah, and
that's right.
It has like preferred directions of force introduction.
It does, yes, absolutely.
So now Spherene, totally different. It's also a minimal surface. It has 2 volumes. And it is not living in a unit cell like the gyroid that you copy and cut something out of.
Okay.
So what you design is you design a sphere, you press a button, and the Spherene comes out. So I'm designing the software, the results, and I'm not thinking about the structure, but I can control it. So next thing, big thing,
Wait a minute. You take a sphere, you put it into software, and the software spits out a Spherene.
Yes. After 3 clicks, you got this.
Okay.
Okay.
Okay, I'm with you so far.
All right. So why Spherene? So we call it a metamaterial.
Oh,
metamaterial, think of it as a solid sphere. It has a specific density. And if I press on the sphere from this direction, the force will go through the whole thing.
Right.
If I press from here, the force goes there from all sides, like a material. Now make it 50% lighter using Spherene. You can do still the same thing with the same material, 50% lighter. So it is yeah, it's isotropic. You may. It is light. It only puts in material where you really need it. It follows the outer surface. It's surface conformal and has these 2 volumes. It's quite a game changer.
Oh. So, here you go. So you get the qualities of having 50% more material, but with that 50% less.
Yep.
That's cool. I can see why you might have patented something like that.
Yeah, you take steel, you make it as light as aluminium, and it will still hold your part. You design your CAD part as you always did. You make it as light so that it just, if you think as material, it just resists all the stress you give it, but it will look like this.
Now, when we think of gyroid as an inner filling for 3D prints, right? That can be built upon many layers. So is this only for spheres?
No. The cool thing is, I brought a bunch of parts.
Okay.
Besides this beautiful collaboration from the Swissman Union, that is like at the Swiss Pavilion. It's like a collaboration of multiple companies, like Ceramic. They made these aluminium parts. Prodartis made the plastic parts. Swissman is the union. Sooner make another plastic part.
Okay.
So it's a collaborative work that we did.
Okay.
But now I show you some stuff that we did.
Oh, okay.
And even more. So.
Oh yeah, bring up some stuff.
Show you more.
Sure. See, we just load the table up. Don't worry, you didn't break it. No. Oh.
Hope it holds.
Not the black one.
So I can explain some more things here.
Sure.
So I told you how to design this. How would you design this?
I would imagine I would need some sort of algorithm to do this. I would need to hand the computer a shape and a parameter or two, and the computer would have to do the stuff.
That is really good. So this is exactly what you do. So the outer shape, you give it the mesh, like the sphere that is full at the moment. Then I cut the sphere apart to make this mesh here. All right, so that's like a banner going out.
Oh, I see.
Now 2 meshes, nothing fancy. Now I start my project in the software, and it automatically makes the first density, like it says, how light you want it. You place 1 point with a value of 10, for example. That's the volume fraction of the result.
Oh, okay.
So it will be 90% lighter.
Yeah.
Then I place another point in the middle.
Right here.
Or here.
Yeah.
And give it a diameter, or 2 points. 1 is in the middle, 1 is here. And these 2 points define like a sphere that pushes this minimal surface away. And that makes this hollow entrance. I didn't model that. It's still a sphere, 2 points for this hollow part. And this mesh here, I tell you have a wall thickness of 2 millimeters, and the structure should grow onto it and get thicker to that.
Oh, I see.
That's it. And I never did anything complicated about the structure.
Okay.
So now you want to change the wall thickness. Here you see it's thick.
Yeah.
On the other side it's thinner.
Oh, it is? Okay. Oh, yeah. So look at that. Show me that. Let's see. Peter's going to get a camera on that. So that hole right there. There we go. Okay, now I'm going to go right to that spot, but on the other, so we got that. So then if we go there and we look right there, see the walls are thinner. There we go.
And it looks organic.
But again, this is still a spherical object.
Yeah.
So then I see what I want to talk about is the non-spherical objects, because I think the value I'm going to see in something like this is being able to be used as inner geometry for things that are not a spherical geometry, right? And so, just right off the top of off top of my head, right there, is this like an insole? No.
That is the first 3D printed shoe, or the second from Switzerland. We got a custom shop, not for cars, but for shoes now in Switzerland. And Reto, the guy from 3D Fit, he bought Spherene, and now he's scaling up his custom shop. He makes hiking insoles, so I was the last 2 weeks, I was in the mountains hiking with my personal insole. He scanned my foot, that's my footbed. Then he put the Spherene for some cushioning, all in Rhino, like in a grasshopper way to place some points there. And he designed a shoe that I can change the top now. So that's a prototype that we hold here. The benefits.
The benefits. So you're still getting structural rigidity, and you're still getting the ability to push on it and have it resist it, but you're using far less material to make it.
Yeah. First that, and now I go downhill. I have protected my knees and my back, because this takes all the damping from the force. Really cool.
Well, just trying to think of a gyroid infill for something like this, then I would be able to bend it in ways that I shouldn't be able to, just because it's directional.
And it would also be more complicated to design anything, because to have the gyroid follow to something, you have to stretch the gyroids, and then it is not a minimal surface anymore.
Okay, I think I'm starting to get it now, because this is great. It's the force that I'm able to exert is even across the entire geometry.
So now about force. So this is like a FDM printed part. It looks like SLS.
It does, yeah.
But it's FDM printed on a Bambu Labs printer. Here you see how we can change the density very fast.
Oh, yeah.
And it looks very organic.
It does, yes.
And what is cool here on this part, we have this little bridge here. And if you gently start pressing here, you see how rigid it is, with almost no material. So here it's flopping, but here already with only 2-3 Spherenes, it is already rigid.
Oh, that is rigid.
So it's super rigid.
Yeah.
And it is printable without support. So there was no support abused on this print, no support used on this one. Another FDM print is that one, heat exchanger demonstrator.
Oh, okay.
So then you can ramp it up, change the print material, go to SLS, resin, make a heat exchanger. Now we get into the engineering part. It's still a demonstrator, but we have this hole for the inlets. We made this cavity before.
Yeah.
So I make an object, like a pipe, tell it, you are an inlet, then it makes a cavity. You see that on the inside.
Okay.
And then you have space to mix the fluid, or to start to introduce the fluid through the heat exchanger. And since we have 2 volumes, it will fill one part and the other part if I want. So it doesn't mix inside. And you see here the outside, like it connects like the big one.
It does, yeah.
Also in a cylinder.
Look at that. And then, let's see, this.
So what does the future look? You know, maybe this topology optimized.
I was just going to say,
things.
This is like topology optimization supercharged with Spherenes.
Yeah. So how do you do normal topology optimization?
Well, normally, I think I got this. Normally, you give it the constraints of where attachments are, and minimum thicknesses, and you give it that, and then it makes a block. It takes a block that's this size, and it starts taking away material and doing stress analysis on it until it has the least amount of material for the stress analysis goal you're trying to meet, right?
Exactly.
Okay.
So how does it look after that optimization?
Well, usually it looks like this organic alien made it, right?
Like a skeleton
like
also.
Like a skeleton, yeah.
So now you have this on your car bumper, for example. It is optimized for these stresses. You bump it into a wall, one skeleton breaks away. Can you drive further safely? Maybe not. Because you broke off one skeleton that was important to the whole integrity of the
But
distribution.
because this is Spherene, if I were to break this off right here, this doesn't compromise the structural integrity across the
Okay,
piece.
if you break off this part, yes, but if you bump it in here, like that, it won't. So this was the original part I printed on a Creality printer, FDM, not a good layer adhesion. And last Formnext, we had 20 people stand on it. Obviously, it broke off at this point first, a little bit.
Last thing they want to show you, then we have to.
All right.
Oh, okay.
But when I stood on in as a last part, it cut away here. So it is still functioning and rigid. And we also have like this table here that Peter Donders did. Maybe we can put it on.
Yeah, sure. Wait, this is a...
It's overwhelming. We should make a second show.
This is a... So the spherenes in the legs, like the force is transferred all the way down.
Yeah. And
Really?
the design is just the hull. You can imagine how the hull looks. And then you press a button, you say how much density you want to have. And Peter also, he did like design the top, so to close up.
Yeah.
But as a design work, you have all this freedom to do.
This makes a lot of sense
Yeah.
to do something like this because this is cool. Okay, I'm on board.
All right.
I can eat what you're serving.
Gotta
is
try
cool.
it out. So my dream project is to have the guitar.
Yeah, David, you see
Using
this
that.
guitar?
So I want to play guitar
With a Spherene
with
guitar
the Spherene
body.
guitar body, and possibly neck too. So that will be
Sure.
soon.
Well, I know that we're running low on time.
Sure.
People are going to want to know more about this. So look at camera one
All
right
right.
there and just tell people, first of all, if they're at Formnext, where they can find you, but also if they're not, where can they go to find out more?
All right. So if you're at Formnext, come back to our booth. It is in Hall 12-1, booth E19, the Swiss Pavilion. The company is called Spherene. You get more information on our website, www.spherene.ch.
Perfect.
Thank you.
Oh, thank you so much. This
Thanks, Joel.
this was amazing. I'll let everybody else kind of clear this off, but I want to thank you for showing me this.
Thank you for having me.
And I hope everybody goes to your website to find out more.
Awesome. Thanks a lot.
Thank you. Oh, you guys. Oh, thank you.
Oops.
You guys got some things.
Should
We have a picture. I'm Peter. We're going to move this last.
Oh, you designed this?
Yeah, I designed
Oh, good job.
So can I have a picture with you?
Yeah, of course. Oh, yeah, here. Oh. This is Peter. He designed it.
Yeah, I'm the man.
Here we go. Wait, no, you got to hold it up. We gotta hold it. Here we go. I'm gonna hold it right here. There we go. Good design, Peter.
Thank you. Love your show.
Well, the show loves you.
I saw your Lamborghini logo for Linus.
Oh yeah, that was great. That was great.
Can you show the
Look
audience
at that.
We have Stratasys next, and then Joseph Prusa and his new machine.
Wait, did you say Stratasys and then Joseph Prusa and his new machine?
I did.
Huh.
All right. Thanks a lot.
Thank you again.
See you around.
Yeah, see you around.
Visit us anytime. We're just around the corner.
Perfect.
See you.
Yeah, so, hey everybody, we're in the home stretch. We've got Stratasys next, and then after that, Joseph Prusa and the Core One, apparently. It's gonna make its debut here on the live show. That'll be fun. Bronheim, did you see Prusa's latest release update? Yes, and you'll get to see it soon here on the show. Peter went full fan. Peter's good people. Thank you, Peter. Love that dude. Oh.
You got a minute?
I don't. I'm on the live show right now.
Okay.
But afterwards,
Okay.
I like tasty IPAs around 10%. I see what you're saying there, Troy. 1066. The Xolo interview was totally mind-blowing. What an incredible device with huge potential. I agree.
Do you need water?
Sure.
Let me
I'll take a sip.
Next guest.
Yeah, yeah.
You ready?
Yeah.
Oh, all right. mic is live.
There we go.
Pounded it. There we go.
Thanks very much. Thank you.
All right, next guest. Peter, here's your phone.
Are we in camera?
Yeah, come on up. Yeah, put stuff on here, and then who's mic'd?
Well, I was mic'd, and then it's just fallen off. So
Yeah, I'll tell you what. Give me a moment here. I'm gonna. Oh, let's see. Oh yeah, you tucked it. Give me. I need a little slack. There we go. Just a little bit. It's all right.
Good.
We got it solved.
We lasted 5 seconds.
We're engineers.
There we go.
Sorry, I would.
No, you go for it, man. Get stuck in.
I gotta get it in there good. There we go.
All right.
There we go.
Nice to meet you.
Dave.
Dave, yeah.
Yeah. Everybody, this is Dave from Stratasys, and we are talking about what today?
So we're going to talk about our new product for the H350 SAF Relife PA12.
SAF.
Yep.
Relife.
PA12.
PA12. So let's break it down. PA12.
So,
a nylon.
Yep. Nylon 12.
Okay. SAF.
Yep. Selective absorption fusion.
Selective absorption fusion. Okay, we got to talk about that. And then Relife.
Relife.
Is this a recycled material?
This is a recycled material. You nailed it. See, we didn't even need to
that.
break it down,
do we? I love this guy right here. Okay. SAF Relife PA12.
Yeah.
Okay, let's talk about that material. So this is a function. This is a new material from Stratasys that runs on, what'd you say, the H350?
The H350. You've
Okay.
got a good memory.
I try. And then, what are the benefits here? I guess, okay, for SAF, what is the benefit of that technology?
All right, well, I guess we'll start with what SAF is
Yeah.
for people that don't know. So it's a powder bed technology. We roll out a thin layer of powder, but instead of using a laser beam, we're going to print a black fluid, and then we're going to use an infrared lamp to selectively absorb fusing energy and melt that powder into a solid.
Selective absorption fusion.
Fusion,
And
yeah.
so the black fluid is laid down in
on top
specific
of the layer of
shapes,
powder.
though.
Yep.
So if we take a 3D model
Yep.
and we do it into slices, then the shape of the model in that slice is where the black fluid is laid down.
yeah.
Okay, cool. That sounds like a fun technology.
Yeah, black absorbs more infrared energy than
It
white.
it sure
so
does.
It's going to melt only that layer. But the big problem in the industry with other powder bed technologies, they make a lot of waste. So luckily we don't have this in the H350. I'll tell you more about why later.
Okay.
But the other technologies, they make waste powder. As the powder sits in the printer, it gets cooked. It gets thermally aged.
Yes. Okay,
Right.
I do know that part. Yes.
So what are you going to do with all this waste, right? You bought it for $50 a kilo, and now you're throwing it in landfill.
Yeah.
Not a
Yeah.
great thing.
No, not at all.
So we can give that a relife, we can recycle it, we sieve it, we put it in the H350, and we've developed a special print mode that is much more tolerant of that waste material.
Oh, okay. So it's not that you developed a new material, you've made technology that can print with that
Yep.
material.
A new recipe and a new printing method to recycle that thermally aged powder.
Okay. Cool.
You want to go another level nerdier?
I do,
How
yes.
much can you handle? Right?
Oh, we get deep nerdy here.
Okay.
Yeah.
Full the way down.
Full nerd.
All
Break
right.
it out.
So look, the classic analogy for polymers is the spaghetti model, right?
Mm-hmm.
So you've got all these spaghettis, some are longer, some are shorter. That's effectively your molecular weight. So that's the number of
Okay.
chains that you've got making each individual polymer.
Okay.
Now, we have a semi-crystalline material, nylon. So some areas, the spaghettis are lined up. They're highly crystalline.
Mm-hmm.
Some areas, the spaghettis are all random. They're amorphous. And the problem is, when you heat powder, nylon 12, you get chain elongation. So the molecular weight increases. And that's the reason, that molecular weight increase is the reason that these other technologies can't print with this waste powder.
I see. Okay. And so then the H350 is just able to print with a higher molecular weight.
Yep. And we're a bit more tolerant of viscosity effects. So powder's like a liquid, it flows, right? If I had a glass of powder and I poured it out, it would flow. If I rolled it, it would flow. So you need a machine that's tolerant of powder that's lost its flow characteristics.
So it can print powder that doesn't flow.
Yeah, or flows less well, right?
Okay, yeah.
Because of the architecture of the machine, the way that we use the augers, the way that we heat the beds, we have a counter-rotating roller to roll out a nice thin layer. So there's a lot that goes into it.
Okay. That's kind of cool.
Very
Being
cool.
able to take advantage of what would have been waste powder.
Yep.
So rather than throwing it out, you can save it and then use it.
Yeah. I mean, you paid $50 a kilo, right?
Yeah.
So the H350 in a single year could print 1,000 kilos. So that's 50K in your pocket that you were throwing in the bin.
That you were throwing out, yeah.
The machine will pay for itself.
That's cool. Can you say what the price of the machine is?
So it depends on where you are and everything, but let's say roughly 250.
Okay.
Yeah.
It's within the standard realm of industrial machines.
We do industrial machines.
Yeah, exactly.
Yeah.
No, and I think that's why a lot of people like to tune in and hear from you,
See what's
Dave,
going
and
on,
others,
right?
because a lot of people understand the consumer side. Many are starting to understand the industrial side, and things cost a lot of money on the industrial side, but they also provide a lot of functionality over time.
And it's about volume, right? Like, a lot of the engineers in my team, we're makers as well. We have printers in our garages.
Can I take this off?
Yeah, go for it, yeah.
Okay.
But what we want to talk about is mass production.
Right.
Yeah?
Absolutely.
How do we scale this from somebody's garage to industry? And what you've got there is a cardboard molding tool.
I was just going to say, this looks very suspiciously.
Yeah, it's just like these fit together, right?
Yeah.
Okay, so this is made from waste PA12. And what happens is a robot comes in with a flat net of cardboard, and then there's another tool that presses this down, applies a bit of heat, and there's a polymer layer in here because this is food packaging.
Oh, okay.
Right, and so heat seals it, and then the robot takes that off and does another one. And how many do you think this robot does in an hour?
Oh, hundreds?
6,000.
Oh.
6,000 an hour.
Okay.
So
it's running pretty quick.
Yeah. Non-stop. So we've got something, right, that was going to go into landfill, and it's not just good for prototypes. We're making functional production tooling. We're making real parts with somebody else's junk.
Right, because this PA12 that may not be even Stratasys material.
No, it certainly won't be Stratasys material. Actually, the H350 will never make waste material.
That's cool. That's cool. You're able to make a machine that can just take waste from anybody else.
Yep.
And make actual product from it. Like this is great. Like you said, 6,000.
6,000 parts an hour. Yep.
And this is tough.
It's a chunky part, right?
It is.
That's the thing.
It feels like this is a chunky nylon part.
Yeah.
I love it.
And that's hard for a lot of people to do, right? We purposely have a brick on our stand, right? Not because we're going to be printing house bricks, but it's because we can do it. Yeah. Maybe. But we just wanted to prove that we have the thermal model that's capable of doing big, chunky parts. It's a lot of heat in a big, thick part. How are you going to stop the sidewalls from shrinking in? How are you not going to get elephant skin on the sidewalls?
Right. Well, and when we're talking about waste material and being able to use it, to make big, chunky parts, you're not looking for low-quality, chunky parts. You're looking for chunky parts, but
it's got to work, right?
It's got to be quality. It's got to work for the purpose intended, and that's important. And the H350 is doing that. It's
cool. So
I want a robot that just makes cardboard containers all day.
Fill them with strawberries.
Sure, why not? That's neat, man.
I'd say it gets better. So that is the same part, same material, but it's been dyed. So obviously that's hiding some of the surface finish there with a nice black dye. You can go one level further and you can do some vapor smoothing.
Sure.
Because it's still nylon 12.
But again, made from 100% waste.
Yep.
You're getting this for free.
Yep. This, I would say, is the first ton scale, 1,000 kilos a year, $0 powder printer.
Yeah.
Yeah.
And the H350 is going to be able to print non-waste material,
sure.
right?
Yeah.
It still does a really good job
so we've
with
actually,
really good material, right?
Yeah. And we've got a pilot customer in Spain. They're called Wheel Green. You can look them up on Google. Go on their website, and they actually swap between. So some weeks they fill the machine with, brand new PA12 from Stratasys, and they print with it to do top quality. And then they've got a factory in Germany, and they take the waste from there, and they swap over to the waste PA12 mode, and they do cheaper parts for tooling and things.
Have you guys done studies to find out what a common waste production of PA12 is for a business?
I've talked to a lot of customers in the last 2 years, and I would say for your average industrial customer, they're throwing away between 2 and 10 tons per year.
10 tons. Tons.
Yeah. So imagine a huge stack of dollar bills, right?
Yeah.
And we're just going to light it on fire and throw it in the bin. Madness. So this, for example, like some of your listeners might recognize
Viewers,
this.
Dave. Viewers.
Oh, well.
This is video, man.
Some of them might not be watching. They'll be
There's
like
video right there.
They'll be busy doing the washing up and just
That's
listening.
right.
So stop doing the washing up and look at the camera.
That's right. Look at the camera. Look at this thing.
All right, viewers. So some of you might recognize this. This isn't a Stratasys material. This comes from another major player. It's a white-filled PA12. And this material is notorious for having a very high refresh ratio.
It's titanium dioxide, right?
Yep.
That makes the white,
That makes
and that
the
probably
white.
plays into the toughness, right?
Because you've got to put a lot more energy in there to
Yeah.
sinter, right? Because the titanium dioxide is reflecting all of that infrared.
Yeah.
So this powder gets baked. Turns out people throw away a lot of this as well.
That's sad because it's probably really expensive.
It's very expensive. Even more than standard PA12,
Yeah.
right? So yeah, so you can do, standard PA12, you can do white PA12. Basically any unfilled PA12 that's waste, we'll print it.
Unfilled, meaning what?
So no glass, no carbon.
Oh, no glass fiber, carbon fiber.
Yeah.
Okay.
Not yet. Maybe.
I mean,
Maybe we're
no
working on
one
some
thought you'd
stuff.
be able to print with the waste powder you're printing with anyway. So then, and you're now doing that. And so it makes sense that maybe in the future you might be able to
Yeah.
do that.
Yeah.
I mean, I would sure having it being filled presents its own unique set of problems when the chaining has occurred and
Again, the flow characteristics, right?
Yeah.
You're putting fillers in there, you've got to make sure it flows, but yep, it's definitely high on the list of things to look at.
But it's cool to think about, like, free parts.
Yeah.
Especially, and when we talk about the price, a couple $100,000, right?
Yeah.
But if a company is throwing away, let's say we split it in the middle and we go 5 tons a year of PA12, then that's sometimes more than that.
Yeah, times by $50 a kilo,
Yeah.
right? Just rough price. That's a lot. But the other thing is the carbon, right? So to make a kilo of PA12 powder, you're going to emit 7-8 kilos of carbon dioxide into the atmosphere just in the manufacturing process.
Oh.
So if we can print meaningful parts without having to make new PA12, we're actually displacing carbon from going into the atmosphere.
Oh, that's cool.
Yeah.
There's always going to be people that they don't care about that.
There's money people and there's environmental people,
Yeah.
and I think we please both.
But that's
today,
just
right?
it. That's just it. You're getting it for free on both sides.
Yep.
Which is great.
Yeah. So we actually had Fraunhofer Institute, which is like a big German research institute.
Yeah, we featured them before. They're good people.
So they did our independent life cycle analysis. So you don't have to take my word for it. I'm the bad guy from Stratasys. Don't believe me.
Someone's going to clip that,
Yeah. You can go and look in the Fraunhofer report.
Okay.
So 90% carbon reduction. Based on standard PA12.
That's cool, man. And to have it independently verified is by Fraunhofer, which they're good people.
Yeah.
They're good people. We did get the wrap-up signal. So what I need to do is ask you to look at camera 1.
Okay.
And just let everybody know where they can go to find out more about this if they're at the show.
Yep.
And if not, where they can go online to find out more.
Okay, so we're on the top floor of Hall 12. Come find the Stratasys booth. It's massive. Speak to anybody with a black shirt. Otherwise, just come check us out at stratasys.com, and we'd love to hear more from you.
There we go. That was Dave, man.
Thanks. Nice to meet you.
Nice to meet you, man, and thanks for showing me this really cool stuff.
Awesome. Well, glad to be on the show. Thanks for having me.
Thanks for being this. All right. Wave everybody, everybody.
Bye.
There we go. Yeah. Oh, thank you, Peter. Let's see. Uncle Jesse, Joel is a machine. Hope that man has plenty of water. Plenty. And Clayton, we miss you, dude. You should be here. 3D Lab, that's cool. That is cool.
Get what you want?
Loved it.
Cool.
Absolutely. Did you have a good time?
Yeah, it's fun. Yeah, he's a nice guy.
And yes, Joe is bringing, oh, look at that. Joe is bringing the new machine. Huh. Look at that. See you later. All right. Well, next up on the show, David, it's got handles.
I'm fine.
Next up on the show is none other than Joseph Prusa and the brand new, you got this, Prusa Core One. Welcome to the show, man.
I mean, it is It is a piece of workhorse.
Look at that.
22 kilos of steel.
22 kilos of steel.
How
with
many?
Lifting handle, the lifting handles are orange on the side.
Can you convert it to freedom units?
Yes, I can. Roughly 50 pounds. Roughly
Yes.
50, yes. Because it's 2.2 pounds per kilo.
Yes.
Yeah. So roughly 50. Roughly 50. Here it is, everybody. This is the Prusa Core One.
Indestructible.
In what? Indestructible?
Yes.
So. Yeah?
I mean, I think we can poke it until it ends up like Elon Musk and Cybertruck.
Well, remember the baseball at the window didn't do much, so we just won't throw any baseballs at it.
Yeah.
So Joe, this new machine, this has been cooking for a while in the labs at Prusa HQ, hasn't it?
Yeah, I think you know, there was a special place between the Mark 4S and XL for something a little bit in between, and this is it. And I am super excited about it. And
someone just wrote in the chat, oh my God, it's Uncle Jesse proof.
Uncle,
he's in the chat watching right now.
Uncle Jesse. That was for you. So we are for practicality. So our doors can open to 180 degrees.
Yeah.
And you can actually switch the hinges to the other side.
Oh, just like a refrigerator.
Yes.
Yeah, you can make it open from either side.
I mean, I think it is the first 3D printer which can do that.
I think so.
And
we'll be corrected in the chat if we're wrong.
I think it is one of those things where 5% of people will love it so much that they will not be able to stop talking about it.
I think you're right.
And the rest do not care. But imagine that you have a work desk in the corner, and on the very right side you want to have the printer, and the doors would be like that.
Yeah.
So every time you want to get something out of the printer,
you have to open it all the way.
You would have to go
around.
Do the reach around. But this, for the first time in 3D printing history, you can switch the doors around.
There we go. Well, in farm applications, which I can see this being a really amazing machine for, you know, you have machines set up on shelves, and if you have something on the far left or the far right and there's a wall, you of course will want to switch the door around because you just want to. Yeah.
I mean, it is the little things. So we in the marketing we are telling about the doors being able to open 180 degrees, but actually the hinges have two indents, so they
I see that.
They can stop at 90. And
wait. Oh, so they've got a detent right there to be able. Oh, that's nice. Look at that. But you know what? One of the things that we got to learn about the Core One is that it can print PLA no problem with the door closed.
Yes.
Right?
Yes.
Yeah.
As it should be.
As it should be. Absolutely. You've got fans in the back right here, and you got these little vents at the top.
Probably with the front camera you can see them.
Well, here, let's turn it around.
Oh, yeah, they can see it.
There you go, Peter, right there.
Two server cooling fans.
Yeah.
Like the fans which can do a lot of static pressure, because
they have to. I mean, if they're server fans, they're cooling server racks.
For normal operation, they are limited down to 40%.
Okay.
But we are keeping a lot of reserve because one of the options we have is the filtration system, the HEPA filter, which just snaps on here.
Oh, I see.
And when the fans need, in that case, the fans need the extra power to push the air through it.
Right.
Yes.
Okay. Here, I'm going to turn it one more time. So look at that. There's an indent where the spool goes.
Yes.
Which is fantastic because now we're not making it larger on the outside, and we don't have a spool in the back.
I mean,
thank the good Lord.
I mean, can you imagine a 3D printer which doesn't have a default spool mount on the back of the machine? But I'm super excited about the smart design because we can have the heated chamber without any additional heater elements, just because we reduce the volume of the inside by these indents.
Oh, that's right. You're taking up air that you don't have to heat.
Yes.
Yeah.
Yes. That is it. I mean, other machines just have heaters to heat up the air in the non-used space. Right?
Well, a lot of times other enclosed machines, ubiquitous across the industry, are boxes. And they're not engineered boxes. They're most of the time they're boxes. And so they don't take into account having an indent to take up space that doesn't need to be heated. Because if we look inside, like there's not a lot of space on either side. You are
exactly.
Most of the space inside is the build volume.
Yes. And I'm super happy that we got to we get to find a use for the indents on the left side, or from your view.
Oh, over
on
here.
the right side.
Yeah.
You can have the filament storage.
There we go. So this side's open. This indent here.
So the other side is the filament storage, but this one is for the community to find uses.
Well, in the video you made, I saw there was build plate storage.
We are providing printable upgrades, so you can store sheets and nozzles.
Sheets, nozzles, print farm tools.
Exactly.
Like all of that next to the printer is more valuable than I can possibly express. Because as you know, we run a print farm now, and like I've talked about, I've hired my wife to run it, and she's like, could we get tools at each of the printers or each of the stations to do stuff? And I'm like, well, yes, that makes a lot of sense to do. And now you can actually hide it within the external volume or the external dimensions of the machine.
And what we found out, and team actually loves it, as everything is made out of steel. Everything is magnetic.
Yeah.
So you can clip anything you want to the machine.
Well, you know that once this is in people's hands, this geometry is really easy to replicate in CAD. And people are going to create models that have magnets and that just fit on a corner or across a side and overlap. And it's going to look, what's his name? Neil, the guy that did some mods.
I know who you mean. But actually, what is special and maybe not talked as much about, we, with this, starting with this, we actually are opening up a little bit more to the user firmware modifications.
Oh.
So if you crack the appendix on your board, you are not losing your warranty. We are just not responsible if your house burns down.
Sure. There's a good chance their house isn't going to burn down.
Yeah.
Yeah. Well, let's talk specs. So inside, you've got an extruder, right?
Yes.
Okay. 360-degree cooling taken from the Mark IV's, but modified to fit inside.
It prints as good as Mark IV's. It prints a little bit faster because on Mark IV's we've had a little bit of a tramming as the weight was accumulating on the print bed. We were slowing down the print speeds and accelerations. We do not have to do this here.
Oh. Well, I saw print times of the group model in the video you released, and it was It was considerable versus the
Yeah.
Mark IV.
It is,
but really still against the Mark IVs.
It is the speed up is not just because of this, because we are faster even on small models. But yes, but at the same time, I think really, if you get any modern 3D printer, you don't have to worry too much about speed.
Yeah.
Right. What is special about us is that we by default ship the machine with CHT nozzle, and that means that you get to print high speed with any material you choose.
That's right.
Not just the high speed PLA or high speed PETG. And you get the same exceptional cooling as on the Mark IVs, and because of the with the materials like PLA and PETG and the cooling, you get the same performance on the overhangs as before, and
which is great.
And you don't have to print with open doors.
That's right. So let's see. Let's some quick things. So 300C on the nozzle, 290, 300.
300.
300C on the nozzle.
55 on the chamber.
55 in the chamber, heated by the bed.
Yes.
So if you set the bed to 100C or 110C, it's still going to use the fans and keep the chamber at 55.
Yes,
Okay.
it is actively controlled.
Yep.
But just because, as we reduced the volume of the inside by the indents, the heat bed is more than enough to heat it up.
Yeah. And then, if I remember right, that build sheet right there is going to be the same size as what I
Yes.
have on my Mark IVs, right?
Yes, that was one of the design requirements from me. That I wanted if someone has a print farm of 10, 20, 100 printers, Mark IVs, I wanted this machine to be compatible. So the print sheets, nozzles, and other parts are print sheets, nozzles are 100% compatible, and most of the other parts are compatible as well.
Okay. That's right, because there is an upgrade path.
Yes. So when you have 40 machines at your farm and you add just this one, it doesn't give you a headache.
I don't have to track a slightly different plate.
Yes.
Yeah. That makes sense.
But I'm quite proud because we squeezed 1 more centimeter of print volume out of the same plate. Because
there wasn't a lot of room to give on those, Joe.
Yeah, but on the Mark IVs, the y-axis limit was 210.
Oh, right.
And here it's 220.
Ah. But, and this is important too, it takes up less room than the Mark IVs, right?
Yes. Roughly 30.
Well, on XY.
Sorry?
So across this dimension, it's still taller than the Mark IVs.
I mean, you see this as a box, and on first sight it looks bigger.
Yeah.
But if you look at if you imagine the space, the minimum space for Mark IVs to work, just because the bed is moving, it is 21 centimeters, so completely to the front, completely to the back, that's 42, another spare for the cable.
Yeah.
And you have the spools on the top. Actually, this is smaller by 30% than Mark IVs and has 30% more build volume than Mark IVs.
That's cool. Well, and in farm situations, when you're putting a bunch of Mark IVs next to each other, you do have the cable on the outside. You may have to stagger them so they can all fit on a shelf, something like that. Having more build volume, but within a smaller volume, is perfect for those who are wanting to do farming. Perfect.
And we are counting. We are ready. if you want to do farm, if you want to build a farm, you can reroute the filament from the side to the back, so you can have the printers like stuck to each other without any space.
Oh, that's right. You don't. So the filament over here,
yeah.
you don't. You can reroute it so it's fed from above or wherever you have your filaments.
Yes, and the fact that we have the high performance fan exhausts makes it much easier to do air quality management at your farm.
Well, I've been to your farm in Prague.
I mean, you've been to our farm, but I think everyone who starts to run more than 40, 50 machines, they start to hit the moment that it is not as easy to manage the...
Oh yeah, well, okay, so people out there don't yet know, but we run 50 machines now on the farm, and we get to do a big update about that later. But in doing 50 machines, we have found out that we have heat management issues now that we have to deal with, and I've started to mitigate that, but...
yeah. I mean, you've been to our farm, and for example, in our farm, each shelf has its own exhaust. It's like I can't remember the English name, but each shelf space has its own exhaust out to through the air conditioning system.
Yeah,
and this will make it so much easier because we have powerful fans here and just connect it to
you
one
have
exhaust.
A magnetic mount here to a hose that goes up. And so you're not having to manage heat dissipating into a space. You actually have a confined space with a single output that you need to manage the heat. And so for farm operation or anybody that's having to manage heat in a room, that's great. But I want to talk about, so if you have yourself a Mark IV or a Mark IVS, you take the Mark IV to a Mark IVS, you use that upgrade path, and then you go Mark IVS to this. There is, you're not calling it an upgrade path, you're calling it a,
it is a conversion kit.
A conversion kit, thank you. You want to talk about it?
I kind of think we are crazy that we take the time to make sure that you can convert the Mark IVS to this.
Well, there is a path from Mark IIIS to this. Because you go Mark III to Mark IV.
Oh, okay, yeah. But
well, I'm just telling you. You're still supporting that platform, and you still technically can upgrade from it.
Yeah.
I mean, there's a lot of new pieces, but
the only official kit we will be offering is from Mark IVS to Core One.
Yeah, that makes sense.
If you get a kit from Mark IIIS Plus to Mark IVS, and then this, you can.
Yeah, but you might as well just buy one of these brand new.
But this is the first for us when we allow people to jump from one line of the printers to another.
Yeah.
It is kind of similar as if we would offer a conversion kit from Mark IV to XL.
Yeah, or Mark IV to HT90.
Yeah.
This is cool, Joe. Well, okay, people are going to be curious about this. What's your price on it?
Pricing is on the website because we have so many currencies. I cannot remember everything.
Oh, so Prusa3D.com. If you go there right now, current price in your currency is right there.
I think people will be pleasantly surprised by the pricing.
I think so. Well, you positioned it between the Mark IVS and the XL, but the price point is much closer to the Mark IVS than the XL.
Oh yeah,
like much.
Oh
like,
yeah. Like definitely, and
you're gonna sell a lot more of these than the Mark IVS.
We were talking about this some time ago, and I think if we would have to compare this to Mark IVS or HT90, I kind of think this is closer to HT90 than to Mark IVS.
Think so?
But price-wise, this is closer to Mark IVS.
Yeah, that's true. Oh, one thing we didn't mention, MMU3 compatible.
Yes.
Right out of the gate.
Yes.
So if you have yourself an MMU3 on your Mark IV or Mark IVS, and you get one of these, you can just do that.
The least wasteful multi-material printing solution.
Through a single nozzle.
Yes.
Yeah, because the XL is very...
I mean, yeah, through a single nozzle.
Yeah.
But we also have the least wasteful multi-material solution with multiple nozzles.
Oh, that's true. Yeah, you got them both.
with XL.
Right.
And I mean, everyone who is doing this multi-material through the single nozzle is using our software.
That's true, huh? Yeah.
I'm happy we enabled it.
I'm happy as well. Joe, I know they're closing up Formnext. Around us, I kind of want to wrap this up because it's going to be dinner time real soon. If someone was to come up to you today and say, you have 30 seconds, tell me why I should have a Prusa Core One, what would you say to them? Say it right to the camera right there. 30 seconds, Joe.
It is the machine you want, the machine which is not just for now. I vouch for the fact that we will be upgrading this for another decade to come. And it is a workhorse which will never let you down.
There we go. Straight from the man himself. Joe, thanks for bringing this on the show, man. I appreciate you. And you know what? I put in my order as soon as the website went live, man.
I've seen the notification.
Was I the first? Was I the first one?
Close.
Yo! Yeah, there's always next year. Well, thanks, Joe, for coming on. Well, here, if you leave this here, you know I'm gonna steal it. So you should probably. David, you want to de-mic Joe?
Oh, yeah.
Thank you.
Hold on, you got it? Put it down. I'm not going to take your mic now.
Are we
doing it now? I'm taking your mic. Joel, you get him in the back. Get him in the front.
No, he can get his own back.
Are we still live?
Yeah, we're still
of course
live.
we're still live. What are you talking about?
We're still live. Now
There we
I'm
go.
going to turn this off.
Yeah. Bye-bye. Bye, Joe. See you later. Have a good time. What? I know, I'm about to wrap it up. Because we just had an amazing time here at Formnext 2024. We brought you some incredible technology. We brought you some amazing people telling you some fantastic stories. And I know my mind was blown at least 5 times, if not more. And we got to follow it up with the first live appearance of the Prusa Core One. How cool was that? I'm tired, I'm hungry, I'm thirsty, and I'm really thankful for the day. And I'm thankful for you because you made it this far. You're awesome. Don't forget to hug each other more, fight for a cause you believe in, and if you're not here, come to Formnext next year. And as always, high five. Yay, we did it! Yay, we did it! I get to press the button.
You get to press the button.
Do.
Awesome. Look at that. Did you see that?
What?
Bing!
Oh, yeah. Yeah, why not? People are excited about that.
You have a